My parents were a bit, in fact, not my parents, my aunt was a bit modern when I was born. So she was like behind all these fancy names. So my brother's name is Jerrymel. So she said that, hey, we should rhyme it. That is the newest trend and all. So they convinced my parents to name me Mary. And so
Nice, sir.
it's kind of, how should I put it? It's a good thing and a bad thing for me because I was finding it difficult during my school days to make people understand what my gender is. Usually they would come and call Merrymel and then look at the girls section, and then I would sneak up my hand saying that this is a boy here. But then people always say that they easily remember my name because it's kind of not that common. So it's good. I'm kind of adjusted with it now.
Sure, sure. Okay, yeah, we'll address you, Mary, then.
Yeah, please. I hope everyone is able to install SQLite and MySQL. Yes, Dr. Shinu, you can take it.
No, I am so glad because multiple sessions are starting at 10 a.m. for us. So glad to see you, Merrymel, and glad to see all of you fresh. And I hope everyone is fresh, right? Not just got up from the bed and sitting in front of the laptop. I saw Ganesh. I saw the
Hi,
rest.
hello,
All of
Dr.
you,
Shinu.
the
How are
rest,
you?
all of you must come quickly and say hi to Merrymel and me. I think that would be helpful. And this is a very very short module, but SQL is a important skill to have, and task of Merrymel is to get the whole SQL in 2 days, right?
Yep.
But that is possible. I mean, because we don't have the luxury of time in this course, and we have too many concepts to learn. So I hope you would appreciate and kind of increase the learning curve as steep as possible and then get the essence of it, because usually for an AI engineer, database administrators or designers, architects, all of them would be there around you, but given a task where you have to set up immediately to design database or create the data mart or develop a quick solution, you must know, right? So this may not be a core skill, but you may need to know this extremely well so that you get the right data into your modeling. That's why this module is, and Merrymel has been associated with us for from the inception of these programs, right, Merrymel?
So,
So he was with IBM. Now he moved to Cisco, but he's with us. So that also, we would want to talk about how our mentors are supporting our programs from the day one. And Merrymel is kind of born and brought up in SQL areas, now moving on to MLAI areas as well. So I'm sure that he will be able to quickly tell you what is important for you to know from SQL perspective, right? May not be everything, but very important concepts. So designing backend, which is important. So for that you need to know the domain. Please note, data SQL has a lot of domain understanding which you have to bring in. There is no AI models you will build without knowing that. So I hope, I think one or two use cases is what Merrymel is building today. One on CRM, right? And
sure,
yeah, so,
check that out.
but there are other areas that if you are interested, please explore yourself. But in your capstone project, this will come handy, irrespective of whatever the domain that you are bringing in, right? So over to you, Merrymel. Happy to have you. And Merrymel is a great teacher, and people remember his teachings lifelong because of the kind of way that he teaches. So over to you, Merrymel. Looking
Thank
for.
you. As always, Dr. Shinu gives an introduction that you are left with nothing else to say. Thank you so much for that. And it's again, it's a pleasure that I am coming back to Reva always. And it's obvious, right? Each time I come back, there is something that is there in Reva that attracts me. So it's kind of happy that I'm back again. Again, so I let's get started because as Dr. Shino has told, this is a link. It's kind of 2 day session, but we have some a bit to cover. We'll try to. So it's like you have a favorite book and then you see the movie, right? Not everything in the book would be there in the movie, but the essential parts would be there in the movie. You get the gist of it, all those things. But again, if you want to know more details, you'll have to go back and read the book. It's the same thing. I'll try to touch upon the important points, the basic points. Most of it might be familiar to you because you might have come across that in your professional life, and you might be doing it on a daily basis. But since to get the things in a flow, you might have to sit and bear with the obvious things that you might be knowing, so that others who are not accustomed to SQL also understands it. So without further delay, I think we can get started. Now, a couple of things before we get started. The first one is, feel free to stop me whenever you have a doubt. You need not wait till the topic is covered. You can stop me then and there and tell me that, hey, I have not understand that. Can you repeat it? I have not understand this, etc. I am very happy to answer till the point everyone is clear with the concept. And I'll try to manage the time as well. No worries on that. Don't think that, hey, am I asking a foolish question? No, there is no question that is foolish. Am I wasting the time of the entire load? No. Any doubt might become beneficial to everyone depending upon what is being discussed. So don't have those inhibitions. Third one, if we are going slightly off topic during our discussions, I might pull it back saying that, hey, we will discuss this one on one. It's not personal, it's just that if, we have to cover certain things, and if the topic goes off, then it might disturb the entire plan, lesson plan. And you can address me Mary, which I've already mentioned. You can address me Mary. You can, I think everyone can unmute and then talk whenever they need. So either I would prefer you to unmute and talk, because I won't be checking out the chats because I will be sharing the screen. So unmuting and asking the doubt would be helpful for me. Again, I think we are very good. I'll just switch off my camera so that I get the entire bandwidth to present. So if everything is fine, can we get started? The main thing. So I missed this main thing. So whenever we take sessions, right? Whenever I take sessions and I ask a question to someone, to the team, to the class, if they don't answer or if they don't give me a response, there are two things that can be deducted from it. The first one is people understood everything and they are happy and we can move forward. Or the second one is no one understood anything and they don't know what to do. Okay, which is easier for me? I'll take the first one because I just want to complete of the portion on time, get done with the session, clear your doubts, whatever that is there. I need to do it on a time. So I'll obviously, if you don't respond to me, I'll take the first one. I'll go ahead. Who is in loss? You people, right? Because you are paying the cash, you are paying fees, you are investing time more than your fees, you are investing your time. And if you're not making maximum out of the session, it's your loss. So whenever, if I'm asking you, hey, did you understand? If there is any doubts, please ask, please respond. Okay. Are we all good? No response. So I'll take the first one. Everyone is clear. And
Yes,
yeah. Okay.
Got it, Mary.
Yep. So let me just start sharing. Hope you can see my screen. The PPT.
Yes.
Yes. Okay. So again, to reiterate the point, I know this first few slides and the first few slides of certain topics might be something few of you or most of you might be already knowing, but just to get the flow going, I'm having these slides so that I can build a story out of it, so that you guys remember why we are learning it, what is the importance of SQL, where it sits in the technology, what is the importance of you guys having SQL in life, etc. So to build that story, that narrative, I have put in certain slides. So just sit through. Again, you might be knowing it, but just sit through. Okay. So we'll get started with data processing, structured data. I know that you had the data processing for the unstructured data in the previous 2 weeks. Next 2 weeks we will be learning about what structured data is, what are the different types of file formats, which one is beneficial for us, which should be used, what is ER model, how do you build an ER model, where does database come into picture, how to analyze the data that is sitting on a database, etc. would be covered in the next 2 days. And through the course, how the planning is, first half from morning till afternoon, I'll try to cover the theory sessions, and afternoon is where people get a bit tired after having the lunch and all. So we'll do the hands-on there. Post that, I'll give you a couple of questions to evaluate what has happened, what you have learned for the day. The evaluation would be on a daily basis, in the sense today I'll teach you what is there, and then you will have questions based on what I taught. You have marks for it. Then again the next week I'll teach you something else. Then I have the evaluation for that. Okay. Regarding the assignments and all, we will communicate with you later, because I need to discuss with the faculty who taught you unstructured and to unstructured data, and get an understanding of what he is doing and how the marks should be distributed, etc. So the assignment part, we will come to that later. The quizzes is what I'm talking about, right? Okay. So to get started, let's try to understand what data is. Okay, so this is kind of a discussion that is happening. So feel free to tell whatever that comes to your mind. So what is your understanding about data? What does it mean? And again, I can't see who is speaking. Okay, I don't know who you are. And the good thing about that is, whatever you say doesn't really affect your image. If you think that, hey, if I say a foolish answer, what will sir think about me? What will Mary think about me? I don't know you. So it doesn't matter. So whatever that comes to your mind is what I need. Okay. So please forget all the inhibitions that you have. Please feel free to tell that whatever that comes in your mind. So all good. So we'll start with what is data. Can someone tell me what data is?
So data are individual facts and items of information. Sometimes it can be
Facts and
new.
items of information. Any other answer? Facts, information. I heard three things: facts, items, information. Any other? Everyone agrees to this, or do you have a different opinion on this?
Any
Anyone?
raw information, that we can extract meaningful insights from it.
Raw information, okay, which can where from which you can extract insights. Any other answers? Well, you summed up, both of you have summed up what data is, but you have added an extra thing to your statement, which makes it slightly incorrect. We'll get to that now. Data is nothing but facts, observations, and perceptions. Okay. Now it can be characters, it can be numbers, it can be symbols, it can be images, audio, or video. This is what data is. Data is totally different from information. Okay, that we need to be very clear about it. Data is nothing but facts, observations. It can be numbers, characters, images, audio, or video. Information is something that you process out of the data. You process the data and you get information. Now we humans does it by without it happens involuntarily. You see something and the processing happens in your brain in real quick time. You don't feel that there is a processing that happens, and that is why people think of data as information as the same thing. You see data and you say, hey, I got this information from this. That is because you already have processed, your brain has processed it, and it gave you that information, right? So data is nothing but facts and observations. The moment you process it, you get information out of it. So these two are two different things: data, information. So data is nothing but raw facts and figures, whereas when you process data, you get an information out of it. Let's see with an example. Okay. Now, does this thing SK01, B3413, NL07, K96, does it mean anything to you? Your brain is now trying to process it, what this could be. This is what I'm saying. I gave you raw data. Now this is where your brain is trying to process it. Hey, I have seen so many patterns. Which pattern is it? What does this mean? This is where the processing is happening. You got the difference, right? This is data. I've given you data. Now you're trying to process it and you're trying to get information out of it. So information is the next part. You process data and you get information. Now I'm trying to help you to process it. I'm telling you that SK stands for a state, Sikkim. 01 stands for the RTO office Gangtok. B stands for the number vehicles that were registered up till 19,998 and 3413 adding that to it. So what does SK01B3413 means? It's the 23,411th vehicle registered in Gangtok RTO of Sikkim. Now I've given you how to process the data and you have extracted that information out of it. Now your brain knows, hey, this is the processing thing that you have to do. And obviously you might have figured out what NL07K96. I know you don't know what 07 and all is, but you know what it is, right? What it is. It's nothing but 12,084th vehicle registered in Dimapur RTO of RTO. So you got the process, right? You have data, which is nothing but raw facts and figures. It has numbers, characters, etc. Everything with you. You start processing it, you get information out of it. So that is the basic difference between data and information. Data is facts and observations. Information is something that you get when you process data. All good? Now, when we talk about data, there can be different types of data. And obviously, I know that you might be already aware of this, the different types of data. Can anyone help me with that? Seems like I've bored you with
Structured
within the
and
10
Numbers.
unstructured. Structured and unstructured, and
Structured. Go ahead. Structured, unstructured, and you have a binary thing there. What happens in the middle then? Structured.
so first category, like
Unstructured.
we can categorize on the structured or unstructured data, and if we come to
Correct.
like what kind of the data, then we can go like, okay, it's a numeric or character or boolean, what kind of
Okay. So I was just looking for the broad one, which is data can be categorized by their structure, which is unstructured data. Then you have the semi-structured data, and then you have the structured data. Okay. Now unstructured, you know the examples, right? The text files, etc. Where I can give you an example like this. You take a PDF file and you can't say that every paragraph contains 5 sentences. Correct? Your first paragraph might contain 2 sentences. Your second paragraph might contain 10 sentences. Your first sentence may contain 10 words. Your second sentence may contain 5 words. There is no specific structure to it, right? That is what is called as unstructured data. And the typical example is your text files, your PDF files, etc. Then comes the semi-structured data. Take the example of JSON and explain it. Semi-structured data is you have a structure to it, but that structure is not generic. In the sense, you take a JSON file, it might have 5 fields and different attributes, values, etc. Another record in the same file may have only 3 attributes. So you can't say that this entire JSON file has 5 attributes. Say for example, you are trying to get the employee data. You have employee ID, employee name, phone number, address, etc. Okay. Now, does that mean that every employee in the file might have a number? May or may not be. Such kind of data where there is a structure, but it's not fully structured is called as semi-structured data. And the typical example is JSON file. Then you have the structured data, where you have rows and columns and everything has an order to it. Usually the rows and column picture comes, if it comes into the picture, it's structured data. Okay. Your common example is your Excel files, CSV files, TSV files, etc. Okay. Again, don't misunderstand or don't get confused with JSON and CSV file. You might be thinking, hey, I can have null values in your CSV file, which basically means that attribute is missing, right? That is what is happening in JSON also, right? No, see, in CSV, you have a column dedicated for that. Whether it's null, empty, NA, that's a different story. But you have a column dedicated to that particular record. On the other hand, in JSON, you may or may not even have that attribute at all. That is the difference between structured and semi-structured. All good? So unstructured, you do not have any structure at all. Example text file. Remember these examples and then it will help you to bring out the definition rather than remembering the definition and then coming to the example. Think about the file. Just map unstructured to a PDF file and then you can understand, oh, what is this? This is what unstructured is, rather than by hearting or remembering what unstructured is and then pulling out the example of PDF. OK, semi-structured JSON file. What is happening in JSON file? I can have 5 attributes, 3 attributes for another record, 2 attributes for another record, 5 attributes for another record in the same file. Though there is a structure, it's semi-structured. Not every record has the same structure. That is what semi-structured is. Structured is you have definite number of columns and every row has all those columns. That is what structured data is. OK, now moving on. Let's try to understand more about unstructured data. I've already explained this, but I've kept it into a slide. It doesn't contain any field, columns, or structure. Doesn't follow any particular format, sequence, semantics, or rules. Doesn't have any predefined data model. We'll come to data models late in our session, but data model basically means that it doesn't have any schemas or any kind of rules. OK, now. Sources of unstructured data could include multimedia files, social media data, docs and PDFs, etc. Are we all good with this unstructured data? It's pretty easy to understand, right? There is no structure at all. There is no rules at all. There is no semantics. You don't know how to make them. Now, you might be thinking, hey, there is something called like text analytics, which I do, right? On top of unstructured PDF files. How does that work? That is where you convert this unstructured data into some kind of structure, right? Where you have built in dictionaries and then you say that if this word comes 5 times, then the tonality is this much. If this word comes only once, then the tonality is 1, etc. So you try to build a dictionary and convert this unstructured data to structured data. Now, why I've told this is, if you see bottom line, whatever data that you have, people try to convert it into structured data, be it unstructured or semi-structured. Eventually, the industry tries to convert it into structured data. OK, so unstructured data, no structure at all. Next one is the semi-structured data. It has some organizational properties, but lacks a fixed or rigid schema. As I told, the organizational property is nothing but, hey, there are 3 attributes and these attributes name is given, the value is given. So there is a structure to it, but it is not followed entirely throughout the file. Your first record may have 5 attributes, your second record may have only 3 attributes. That's not followed strictly. And it cannot be stored in the form of rows and columns again, there's a disclaimer there. I know there are databases like MongoDB, etc., which takes in JSON file and then helps you to see it as rows and columns. The idea here is, since you do not have all the columns for all the rows, you can't theoretically say that it has all rows, and it has all columns, and hence you cannot store it as rows and columns. It's a theoretical concept. I know practically what is happening, but it's a theoretical concept that it cannot be stored in the form of rows and columns. OK, now it contains tags and other markers to separate semantic elements, to group and organize it in a hierarchy. So when you take a JSON file, you know the markers, right? Tags, tag value. So it would be the column name and the column value for that record. Like employee ID might be Rahul, his employee name might be Rahul, employee ID might be 1, etc. So your tag is employee name, the tag value is Rahul. So that is what tag and markers mean here. Source of semi-structured data could include emails. Your emails is considered as semi-structured data, XML and JSON files, binary executables, TCP and IP packets. All this comes under the classification of semi-structured data. OK, now moving on, last one, the structured data, the most common one, the most familiar one. It has a well-defined structure. You know how many columns are there, what each column is. It adheres to that defined model. It knows that there should be 10 columns, then all the 10 columns would be there for all the rows. OK, and their data types also would be known. conforms to tabular format. Basically means that you can write it as a table where you have rows and columns. The sources of structured data could include your most famous SQL DBs, OLTP data, which is nothing but online transaction processing, spreadsheets and forms, CSVs, etc., CSV, TSV, etc. All those. So to revise, we have three types of data: structured data, unstructured data, semi-structured data. Structured data where you have a structure, Excel is the example. Unstructured, you do not have a structure, PDF file or document file, text file, etc. And then you have semi-structured data, JSON file, where you have certain organizational properties, but it's not adhered to strictly in the entire file.
Very Ganesh here.
Yes.
So Mary, I had this question before also. So why did the industry conform to a two-dimensional, and we repeatedly say like it conforms to a tabular row column?
Yeah.
Why are we not talking about
Understood.
three-dimensional, four-dimensional, and so on?
Oh, that three-dimensional. Oh, that's a good question. Why didn't they? So we do have geographical data being utilized now, right? Spatial data. So there is a separate. How should I put it? There is a separate set of DBs that is coming up where spatial data is being used, where you have three-dimensional data being used. That is there actually. It's just that it's not that common. That's the only difference.
Okay.
You have the idea of graph DBs and all, right? So there are certain graph DBs which are three-dimensional as well. What we have seen is a two-dimensional one where we have a root and then the leaves. That's all. Now again, there can be adjacent leaves which are in different axes. So that concept is also coming. So say for example, in your company hierarchy, right? You see a pyramid model. Now this pyramid model, when you see it looks like a triangle, but actually it's a pyramid. So people are trying to replicate that in graph DBs as well. So to answer your question, yes, the industry is moving towards that spatial. Now, why we are still not why it is not that common is so I don't have those slides here, but I usually teach them for the big data course. So there is something called as evolution, data evolution. OK, and this is not confirmed by anyone, or I have read through many blogs and I found out that, hey, this is how data evolved over a period of time. OK, so I'll just give a small brief about what data evolution is. So right when we started the concept of data, it was all whatever that was there was business data. Business data in the sense you were doing transactions and people used to record it, right? You went to a bank, you did some transaction, they record it. That's the initial thing that was happening, the business data, right? The transactional data. Now, if you 10 years back or maybe 15 years back, when you went to a bank, what was it that they were doing? They wrote the transaction into a book, correct? They were writing it into their logbooks, what happened, what is the amount, etc. And if you have seen it, if you have noticed it, you might have obviously noticed it. They were not writing stories in it. They had proper rows and columns, right? They had a column for what is the bank balance, what is the date at which amount was debited, what is the amount that was debited. You have your passbook, which is in the form of rows and columns. What is the reason that it was in rows and columns? Because people, humans, we knew that if we write stories, it will take more time to analyze. See, if I write, instead of having rows and columns and date and all, if I had written, if my bank accountant had written, Merrymel came today morning 10:30 a.m. He withdrew 250 rupees. So now his balance has become 150 rupees. If my accountant was writing stories like that, it would have taken more time for him to analyze, right? What was the transaction for a third person as well. And that is why humans were intelligent. They knew that what if I write like this? When did he come in one column? What was the amount he debited? I can easily read through that and understand what happened. So humans were intelligent and they wrote it in rows and columns. And that was the beginning of the introduction of structured data. whatever that was happening, we tried to convert that business or transaction into structured data. And this was what was happening in the initial times. Now, who was doing this analysis? We humans sitting manually looking through it and then analyzing it, right? It was manual work. If my manager comes and asks me, hey, what is the balance in Merrymel's account? The accountant has to go look into the book and then manually say it. Then people started thinking, hey, why can't I develop a machine wherein I can store this data, and if I write a query, it gives me the result for what I'm looking for. That led to the development of something called as the machine era. The first one is called as the business era. Now it is called as the machine era, where you have the machine, you store the data there, you ask the question and you get the answer to it. Now, specifically, one type of thing was developed, which was DBs, database. Why database? Because the demand at that time was to store what kind of data? Structured data. Because your data that you were having was structured data. The only thought process at that point of time was, I have structured data. I need something where I can store the structured data. I need something where I can ask a question and get the answer. And that specifically led to the development of DBMS. And all the business came into DB. Everyone was happy going through the business transactions, etc. Then came the era of mobile phones, social media, etc. People started using different things. People started generating data in addition to the business data that might become relevant to business. Say, for example, earlier, whenever you used to buy a car, after 3 months, Maruti Suzuki used to send you a feedback form by post. You fill that, you send it back. And that is how they used to collect the feedback from the customer. They were trying to find out how satisfied the customer is. But how did they do it? They send a feedback form, you fill it and you send it back. And then they give you a gift for that. That is how they were collecting the data. Now, with the introduction of social media, with Twitters, Facebook, etc., people started putting reviews in Facebook. People started putting reviews in Google, and companies or organizations realized that, hey, this user generated data, if I can analyze that, in addition to whatever business data that I have, like how many sales did I do, how much sales did I do, how many cars did I, all those things are business data. I have it in my DBs. But what does the customer think? They have put it out there in social media. How can I take that? How can I utilize it so that I can make my product better? Say, for example, when iPhone 12 came out, and this is happening a recurring thing, but then when iPhone 12 came out, people started tweeting that the price is it's overpriced. Then they started slashing the price. How did they do that? They took the sentiments from social media rather than going and asking different people. They took the sentiments from Twitter and they analyzed it, and they found out that a majority of the people thinks that it's high priced. Let's reduce the price so that it becomes more favorable for the people. Now, what is this data? This data is called as the user data, and it's called as the user error, where companies realize that there is a lot of untapped data, untapped user data, which I can use to improve my business, to improve my productivity. But the problem with this is it can be structured, it can be unstructured, it can be semi-structured. You do something as a post in Facebook, that is unstructured. You tweet, you pull that tweet, it comes in as a JSON data. You give a feedback form, you respond to a feedback form, that is a structured data. All the three types of data came into picture. Now companies started thinking, oh, user error data, I don't know what to do. This all led to the development of what is called as Hadoop. The demand for big data, the demand for Hadoop came in there. Now, in addition to this, so I've taken you through business era, then you came to the machine era, then you have came to the user era. Right now, we are in something called as a digital era. What is digital era? Nothing but user era data plus machine generated data, which is nothing but you can call it as IoT. What is machine generated data? You started attaching sensors to your machine parts, and it started generating temperature, like what is the temperature of that, or how much what is the sensitivity of that, all those things, and you started collecting that data as well to analyze it. This is the extra thing that came in. User data, we are generating it. In digital era, in addition to all the data that is there, machines also started generating data, which we started analyzing. So currently we are in digital era where we have a lot of unstructured data, a lot of semi-structured data, and a lot of structured data. Now, over the period, if you see, one thing has been common, which is structured data, and that is why it is more famous. It's very famous, but people have realized the importance of unstructured and semi-structured data, and that is why you see a lot of opportunities in big data these days. You understood, right? And now to the question that was asked, what about three-dimensional data? People have seen a niche there as well, and they have started developing spatial databases. They found out that, see, for example, one of the use cases, uh, Uber, you are trying to book a taxi with Uber. OK, let's say that you are standing nearby a lake and the road that comes is surrounding the entire lake. But the diameter of the lake is so less that if you book a cab, the cab on the other shore might get booked because the aerial distance is lesser than the road distance, which actually is a problem, right? You get it. This happened to me as well. So when I was in Cochin, I tried to book a cab. I was actually in one part of the place, and the cab got booked in another part, and there was no direct route to me. It was just because of the aerial distance. So all these problems are coming into picture, and people have started thinking, how can I solve it? What if I had taken a three-dimensional data there? I would have understood that, hey, this is how it is. The road is also coming into picture. So to incorporate all those problems, they are moving towards spatial data. So we are into the space of spatial data. Maybe 10 years or 20 years down the line, spatial data might be the only thing that might be existing. Your two-dimensional data also might be represented as a spatial data, wherein one of the dimension is null or something of that sort. OK.
Mary, that was really brilliant. You made my day. I'm glad that I asked that question. I always felt
I'm happy that I was
uncomfortable. I always felt uncomfortable whenever I see rows and columns conforms to tabular data type. You mentioned stories twice.
Yeah.
So because time to time our society has evolved, the
Correct.
society has evolved because of the stories, which is
Correct.
an unstructured data, right?
Right.
Okay.
Right. And exactly. So again, people are in a state where you are right now. How can I solve this problem? That will definitely lead. Necessity is the mother of invention. That is where it goes to the next level. People start thinking, hey, I need this. And we are moving to that. We have spatial databases that are coming in. Almost like all the transportation companies are moving towards that direction. Yulu, your bike renting app, right? The cycle renting app, Yulu. They are trying to. My friend works in Yulu. So he was specifically asking, how can we solve this issue? It was just a casual talk, and he was telling that is something that they're trying to solve right now. So that is how I know the details. I was giving you the example. Okay, so
Great,
let's move on.
Thank you.
Next one. Thank you. Welcome. Types of file formats. So we saw what are the different types of data. Now this data can be in different files, right? So we'll understand what are the different types of file formats. Okay. Now, why should you know about the different types of file formats? Because there are specific files that are suited for certain DBs. There are specific files that are suited for your laptop. There are specific files that are suited for Hadoop, etc. So knowing the type of file formats will help you to identify the best file format which has the best performance based on the use case. Again, disclaimer, it depends on your use case. Okay, some people comes and usually the question that I get is, should I learn R language or Python language? And most of them answers it as Python. But I have a very different opinion about it. I say it depends on your use case. If it involves a lot of statistical calculations, go for R. If it involves just machine learning model, you are not required to understand what is happening beneath, but you have the data. You want to check whether which model works for it, find out what the predictions are, go for Python. So it depends on the use case. It's like asking me which is a good language in Karnataka. It can be Hindi. It depends on the person whom you are talking to, right? That is the same scenario here. Which language is better depends on your use case. Similarly, which file format is better depends on your use case. Now, there are certain file formats or certain use cases, or how should I put it? I'll put it in the other way. Python might fit to a large amount of use case, and that is why people prefer Python over R. And that is why when people ask, should I learn R or Python? People usually say Python. Why? Because there are a lot of use cases that can be covered in Python, and that's why it becomes popular and people prefer it. Similarly, when you check for best file formats, you might see Avro, you might see RC, you might see ORC, etc. Why they say that this is the best file format? Because in majority of the use case, it shows the best performance. Doesn't mean that every use case that you take, this is the file that should be used. It depends on the use case. Okay. Now, the different types of file formats are, as I told, you can have the delimiter files where you have space, hyphen, or comma separator. Then you can have JSON file, XML, Apache ORC. ORC is optimized raw columnar. It's all high topic for us. We don't have to, it's out of scope for us. Usually this gets covered in the big data part, but again, just understand that all these are there so that when someone talks about, hey, I'm working in Parquet. I have heard about Parquet. It's a file format. You shouldn't be confused. What Parquet? Is it a technology? Is it a tool? So you just know what it is. And if you have, again, as I told in the beginning, I'm just showing you the film. If you want to know more, just read the book. So you will have to research a bit from your end because of the time constraint. Okay, so the different file formats, Parquet, ORC, Avro, XLSX file, XML, JSON, delimiter. In your delimiter, again, you have the subdivisions like TSV, CSV, etc. So many are there. Okay, so these are the different types of file formats. Now, delimited files, as I told, this data is stored as text. You can have comma, tab, or semicolon, colon, etc. All these are delimited files. CSV files, your TSV files, etc. are all delimited. Then moving on, you have the Microsoft Excel. I'm just running through this because you are all familiar with it. Okay, it's nothing but it's a Microsoft thing. You have XLS file where you have the sheets, rows, columns, cells, values, etc. It is a secure file format, and because all those protections are there, it cannot save malicious code, etc. So all these are the specialities. Next one is the extensible markup language, or XML. It is for encoding the data. It is human and machine readable. It's a self-declarative language. Probably all of you might have seen the XML files, right? It has that tag and then a set of statements, which is the header, value, etc. All those things. So it's a self-declarative language. It's platform independent. That is the major benefit of it. You take an XML file, you take it from Windows, you put it into Ubuntu, Linux, doesn't make a change. Okay, and it's programming language independent as well. You can use it for any, be it a Python API, be it a Node.js API, XML file can be used. And it simplifies the data sharing. Obviously, since any language or any system can use it, it becomes easier to share the data from one system to another system through XML files. Next one is the JSON file. You already know what JSON file is. You have the tags, markers, etc. It's readable in, again, it's similar to what XML is, but it's more readable for us than XML. There is a specific structure, semi-structure to it, which helps you to makes it easily readable, easily shareable, because it's language independent, it's platform independent, etc. Moving on, so types of file format, it's just for your information. Okay, you might encounter all these different file formats in your life. Eventually, you are going to convert it into structured data, and that is where the importance of processing for structured data comes into picture. Now let's try to understand the modern data ecosystem, where what comes in, who is utilizing it, etc., so that you get the entire picture of what is happening in the industry. There are a lot of systems that are interconnected. They might be sitting independently, and they are continuously evolving. We already came through the part of that evolution, right? It was structured data, unstructured data, semi-structured data. Now you have spatial data. That evolution is continuously happening. Now there might be things that you might not be able to picture now. You might be able to picture at 20 years later, telling that, hey, you can add one more dimension, a fourth dimension, which is something else. You are not able to picturize right now, but as and when we evolve, you might think about adding new dimensions to it. So all these systems are interconnected. They might be sitting, they are sitting independently, they're generating their own data, but this data can be connected to some other system, data can be joined to some other system, and each of the system is continuously evolving. Okay, data is generated from disparate sources. Different types of analysis and skills are needed to generate insights, because earlier someone who knows to write SQL or someone who is good in data warehouse was the one who was paid highest back in 2000, maybe till 2012. Whoever who knows SQL was someone, whoever who knows ETL, whoever who knows Informatica used to get, Informatica is a tool that is used for ETL, used to get the highest salary. Then slowly it shifted. People realize that, hey, it's unstructured data that makes up 80% of what data is. So someone who knows to tap that, untap, or get insights out of it is more relevant right now. And so the skill set started shifting. It started shifting from just SQL to knowing Python. It shifted to knowing R, it shifted to knowing how to do text analytics, etc. So you need to have different skills, different types of analysis are required to analyze the data, different types of skills are needed to generate insights. Now, all these data that is generated, all these insights that is generated are being given to different stakeholders. And these stakeholders also need different types of analytical skills and different types of analysis to understand it. The data that you give to a data scientist may not be the thing that you might be giving to a business analyst, because they are two different people, two different sets of people with different skills, different capabilities to analyze data. And so the data that you cater would also be different. And in addition to this, your ecosystem helps you to do all this with different kinds of tools. As I told you, have your Cognos, you have your Tableau, you have your Excel, you have your Python, you have your Pandas, NumPy, etc. All these different tools helps you to understand, analyze, generate insights of this data. So your data ecosystem right now have a lot of data sources which are in different sets altogether. They are disparate, they are interconnected, they stay as independent, they are continuously evolving. People who are working with it require different kind of analysis to understand it, different set of skills to understand it, different set of skills to portray the data, and for that you have different tools also available. This is how your modern data ecosystem exists right now. And the different data sources, just to add to the previous slide, it can be text file, it can be IoT, it can be big data, it can be streaming data, it can be your normal RDBMS, it can be image data, video data, multimedia data. There can be different data sources. It's diverse and dynamic. And the first step that you have to do when you have a data source is to copy it into a data repository where you can acquire the required data, work with the data formats, sources, and interfaces for data pull. Then what you do after that, you analyze it, you make it reliable, you remove all those bad records, bad formatted records that doesn't make sense, so that your data becomes reliable. You make it secure so that there is a level of security to it, and you make you put an integrity to it. You tell that, hey, this data, you can use it, it's correct. You can rely on it. The data is secure. So this is how the current scenario works. You have data in different source, you bring it to a data repository, you do all the things to make it reliable, secure, and integrated. First basic thing that you do is data processing. Your data is sitting in your data repository. You need to process that data. It has to be cleansed, organized, It has to be optimized for access, and it has to conform to all the compliances. It can be business compliance, it can be your database compliance, it can be your model compliances, etc. We'll come to that later. OK, but this is what data processing is. You clean the data, you organize the data so that it becomes optimized for access and it conforms to different compliances that are put into place. So the modern data ecosystem has different data sources. The first thing that you do is you bring it to a data repository. Then comes the data processing part. It's in the data processing part that you add those labels of security, reliability, and integrity to it. How do you do that? First thing that you do is data processing. You clean the data, you organize it, you optimize it, and you add it, you keep it compliant so that there is security in place, there is reliability in place, and there is integrity in place. Secure repositories, which I've already covered. Now, after this, you process the data, you put it into the MDM, which is master data management, which is nothing but there should be a system in place to check everything is happening properly. Right? That is what is called as MDM, master data management. You manage, you have a system that makes sure that all these things that has to be done in the data processing has been done and is then kept into the system. That is where you have the MDM in place. Again, I'm just giving a overview of MDM. If you go to fine details, it has many more features, many more flavors to it. But just the idea here, what is master data management? You check whether whatever that you are supposed to do in the data processing has been handled and done properly. That's all. And the last one is from your MDM, it goes to different apps, different use cases, different people, different stakeholders, etc. They analyze it. And this entire thing comes, you can in a way think as the a basic pipeline of the industry. You have the data somewhere, you bring it to a data repository, you process it, you make it, you put it into MDM, and that is used. Now, which is the basic stone here, which is the base foundation here? Data processing. If you don't do data processing, you can't put it into MDM. It's not managed properly, which means that it doesn't make sense for the business stakeholders or any upstream, any downstream application to use it, right? So the basic step that you have to do is data processing. And in that, we would be learning about how to process the structured data. Now, as you see, the technology and the system, the ecosystem is moving towards more cloud technologies. There is a lot of ML models running. There is big data coming up into the picture. All these things are there and everything requires data processing. And there are a lot of data professionals coming into picture. I mean, they were existing. Now there is a clear boundary to which what they are supposed to do. You have data engineers, you have data analysts, you have data scientists, you have business analysts, etc. And I hope you know what is the difference. I'll just give a brief about what each of them do. Data engineer is the one who is supposed to connect, find out the data source from which you can get the data that is required for the business, connect, build in all those connectors, find out the connectors to connect to that data, bring it to the repository. Then comes the data analyst. What do? They clean the data, they do an initial analysis, they check whether there are missing values, there are data that doesn't come to the, if it was supposed to be a phone number, whether there is phone number itself, whether it's a 10-digit number or more. If it's 10-digit more, discard that data. They try to analyze, do an initial analysis, clean the data, make it into a format that can be given to the data scientist. Data scientists might need certain columns in certain format, in certain file format. They might be needing it in CSV itself so that they can run the machine learning model. Data scientists, they build the model. They build the model that can be run on the file that is provided by the data analyst. And from there, data scientists, after having run their machine learning models and going through their statistical knowledge, they come up with findings. This would be converted into business terms by the business analyst. That is what the business analyst does. Telling that, hey, my mean R squared value is 3.2. Doesn't make any sense to a business analyst guy or a CEO. the data scientist might find out the mean R-squared value for predicted values, and he will say that this model is the best thing, etc. But it has to be converted to business terms so that the CEO and the CFO levels understand it. That is what the business analyst guys does. They say that if you put in if you manufacture 1,000 units of so and so product in so and so place, then you make the maximum profit. That is what our data scientists told me from their machine learning model. And this is accurate to 95%. This is accurate to 80%. This has to be converted to business terms. That is what business analysts do. They again go to CEO, tell them, and then the CEO might say, no, we need more profit. Then they come back, they communicate it to data scientist, who then communicates it to the data analyst. The business analyst guys might tell, hey, the CEO is looking to start a new unit in Bangalore. What is the ideal place to start it in Bangalore? Whether it's Whitefield, whether it's Mathahalli, where should I open my unit? What does the business analyst say? Do they go back to data scientist? They ask them to predict the place. The data scientist might find out the features that might be influential. They give all these features to data analysts. Data analysts ask data engineers, hey, tell me where is the maximum footfalls? How many of the people have tweeted about so and so malls, etc. Get me all those data. So the data engineers get that data, data analysts analyze it, removes the unwanted data or removes the irrelevant data. Data scientist runs their model, find out the top 10 features out of the available 20 features, and then convert it into a model that predicts it to the maximum accuracy, which is again converted by into business terms. Business analysts would say, if we put in a store in Marthahalli, that could give us this much profit. Why? Because there is a theater nearby, so the people who comes to the theater might get into our shop, etc. So all those business terms would be brought in by business analyst. Okay. And next thing is, you know what is data, you understood what is data, what are the different types of data, how you process, or what is data processing, where does it sit in the modern data ecosystem, who all are using it, what are they using, how are they using, etc. Now, here comes the what is being done part. Okay, the data analytics. Can someone tell me what is data analytics? What is the first word that comes to your mind when you hear data analytics? I'm just making sure that no one is sleeping. So I'll keep on asking questions. Analyze, correct. That is the exact word that I was looking for. When you hear analytics, the first thing that comes to your mind is analyze. So what are you analyzing? You have business data. You analyze it using what? You use softwares, tools, statistical knowledge, etc. to analyze the data. Now, what is that? You analyze the data using all this. What is the benefit of doing that? You get insights and patterns. Well, you analyze the business data using statistics and software knowledge. All this is good. You found out insights and patterns. And what is the output of this? What is the end product of this? After you do all this, what is that you are gaining out of it? Can anyone tell me?
Business ideas.
Information. Decisions.
Okay, keep on. You are talking about, how should I put it? There is a one major word which has all this as the sub branches to it. Can you try to find out the final word? After getting to know all these things, you make
a decision.
Better decision. Correct. It's not just decision, it's better decision. Okay, I'll give you an example. Okay, so imagine that you are coming to Reva University. Okay, you are staying in Mathahalli. Okay, or let's say you are staying in Kaban Park. On the first day, you took the road. You took a particular route, route A. Okay, it took 45 minutes for you to reach, but the cab fare was 120 rupees. Okay, on the second day, you took another route. It took you 1 hour to reach, but the cab fare was only 100 rupees. Okay, now on the third day, which route will you take? I know you are confused, right? The question is, should I be considering price as the factor or time as the factor? That is where you take the better comes into the part, right? The better decision based on what is required. Going through route A is a decision. Going through route B is also a decision. But which is the better decision for you for the best outcome for your use case? That is where you use the analysis, right? You had data of 2 previous days journey timings and price, the cab price. Then what you did, you analyzed it and you found out the pattern that route A took 45 minutes, but it cost me 120 rupees. Route B took 1 hour, but it cost me 100 rupees. On the third day, if time is my priority, the better decision is go to route A. But you can also take the decision of going in route B as well. But the better decision is going to route A. Now, if the use case was, hey, I have enough time, I want to save some money, then the better decision is going through route B. And that is what data analytics is. You analyze the data using statistics software, you get insights and patterns, and you make better informed, educated decisions about what is best for the outcome, but what is best for your use case. That is what data analytics is. So whenever someone asks you what data analytics, remember this example. Two routes. I have two things to consider: price, time. So I analyzed it. Which one is better for me depends upon what I'm looking for. And then depending on that, you take the better decision. Not a decision, it's a better decision. OK, that is what data analytics is. Data analytics, you make decisions, which is better. Now, there are different types of data analytics. Can someone say, help me, how many types are there and what are the different types? Anyone? You might have already learned this in other modules or topics, but just for a refresher. One analytics, I'm pretty sure everyone knows this because it's highly popular in the industry. One type of analytics. Can anyone help me? The types of analytics. So what is going to happen is I'm getting familiar with the voices. OK, I know that there are only specific people who are answering the question. If they continue to do that and others continue to keep quiet, what I'll do is I'll just pick randomly. I'll go to the chat section, pick a name randomly. I don't know who you are, so I'll pick randomly and I'll ask you a question. So it's better that you tell something so that I hear so many different voices and I think that, hey, everyone is participating in it.
So it is
What
like predictive data, predictive.
Correct. Predictive, the most popular one.
Diagnostic.
Prescriptive, predictive, prescriptive, then
descriptive,
diagnostic,
descriptive, and diagnostic. OK, so all the 4 types of analytics you have said it, but there is a problem with it, which is there is a specific order to it. OK, you have to say that in the order itself. It has to be descriptive analytics, followed by diagnostic analytics, followed by predictive, and then prescriptive. This order has to be maintained. What does why I'm sticking on to the point that the order has to be maintained? Because you can't have a diagnostic analytics without doing a descriptive analytics. You can't do predictive analytics without doing diagnostic analytics and descriptive analytics. And again, prescriptive. You can't do that without having a prediction, without diagnosing what the issue is, and without describing the issue. Clear? So what this has to be remembered in order: descriptive, diagnostic, predictive, and prescriptive. Now, I'll give you a simple example or simple real life case so that you remember this. OK, imagine you fell ill, you have some disease, and you went up to the doctor. What is the first thing that you do? You describe him what you are going through. Correct? You say that, hey, I have headache, I have chest pain, all those things. You're describing, you're telling what is happening to you. That is descriptive analytics. After hearing all this, what does the doctor do? He diagnoses it. Oh, so this is the symptom. So this is the problem. This might be the disease that you're having. What is he doing there? He's diagnosing it. Then what will he do? He will say that, hey, this might go for a couple more days like this. You might have, or this might become severe, or it might get better as the day goes. What is he doing there? He's predicting what is going to happen. And the last one is, right when you're going to leave the room, he will give you prescription, right? He's telling you this should be done. So you went to the doctor, you said what you are going through. That is descriptive analytics. What is answered in descriptive analytics. Then he diagnoses. The doctor diagnoses what is happening there. Why? He's giving you the answer for why. Then he does a predictive analytics. He's telling them what will happen in the future days. And right when you're going to leave, he gives you a prescription. What should be done? So it comes in the order: descriptive, diagnostic, predictive, prescriptive. Next time when someone asks you what are the 4 types of data analytics, remember going to a doctor. Everyone has been to a doctor, has went to a doctor at least once. Remember what you did. You went descriptive analytics. Then he did the diagnostic analytics. Then he said a predictive analytics. Then when I was leaving, he gave me a paper, prescriptive analytics. All good? Descriptive, diagnostic, predictive, and prescriptive. This 4 has to be in the order. Descriptive, what happened. Diagnostic, why it happened. Predictive, what will happen. Prescriptive, what should be done. Okay? All good. Let's bring everything together and see the full picture. So you have data repository where the data is sitting. You do data processing so that it becomes available for data analytics. From there, you bring out better decisions. You take decisions. Data repository to data processing, data engineer, data repository, data engineer takes care of it. He will bring the data from different places. Data processing is done by the data analyst. The analytics part is done by data scientist. The model building, the predictions, all those things is done by the data scientist. And last, it gets converted to business terms so that better decisions are made, is done by business analyst. All good. Where each people sit, where does data processing sit? Why is it important? Because downstream, everything depends on what your data is. You can get data from everywhere. Data is there out. You can pull it from any source you want. But unless and until you process it start to get information out of it, it can't be used for analytics. It can't be used for making better decisions. And that is why data processing is important. All good, everyone? Any doubts? Any questions that you have? Anything from the slides that we saw?
I have a question.
Yes.
We have understood about analysis, what we do analysis, and at what level we do the analysis. It's in data processing mostly that we do the analysis. And analytics, in data analytics, mostly data scientist who works and applies different analytics to get the informations, right?
Yeah.
And then finally we get the information, the insights to make any decisions. My question is a very basic question. So what is the difference between analysis and analytics?
So the definition itself is, so I'll give you a simple example. I'll try to say, tell you with an example. See, say that your data engineer, okay, gave you the data of different cities to you. Okay, let me think about a use case. Okay, I'll take this use case of starting a shop. Okay, you are a famous brand, a chain market business, and you have let's say that you are a grocery shop and there is you are a famous chain like DMart, and you're trying to find out, you're trying to open up a space in Bangalore. Okay, and you are there in all other cities and you're trying to open up a space in Bangalore. Now, the business analyst wants to find out where this location should be. Okay, now your data that is there in the repository might have details of all the cities of India. Okay, like Ahmedabad, it has so much population. In Ahmedabad, you have so and so major towns. The population is this, the demographics is this, the number of the demographics is this, the land is this much, the vacant land or the buildings that are available for lease is this much, etc. So for Ahmedabad, you have, for Bangalore, you have, for Delhi, you have, for almost all the major cities in India, you have data in your database. The data engineer has extracted data for you. Now, what is the relevant one for your use case right now? Bangalore. Who analyzes that data and gives that data to data scientist? The data analyst. He analyzes that data. He says that, hey, I have so much data. No, the use case is only for Bangalore. I don't want Ahmedabad's data. I don't want this data unless and until the data scientist comes and asks me, hey, uh, 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 okay, I'll come to that later. So the only thing that is needed right now is Bangalore data. That kind of initial analysis is done by data analyst. That is what analyzing the data is. Now you take that data again. Another step to this analysis is you analyze the data, and again, as I've been repeating, you remove the bad records, which doesn't make sense. You remove the irrelevant record. So if you're trying to start it in Bangalore city, any records that is in the outskirts of Bangalore doesn't make sense, right? So you remove that. You start a DMART in I'm just taking an example because I'm based out of Bangalore. My work location is Bangalore. I don't know if everyone is out of Bangalore, but still, I'm just taking that example from Bangalore. If you have kept your, if you go and keep a DMART in Tumkur, it doesn't make sense. Though it can be considered to be the border of Bangalore, it's the border of the Bangalore. So such records need not be added. All these initial analysis is done by data analyst, and then he gives this data to data scientist, who then tries to find out different patterns out of it. He will try to find out, hey, if there are so and so people, or if there is so and so demographics, if there are so many families, then that is where a grocery shop makes sense. Now I see the demographics, families to be more in so and so location. And again, all those locations nearby this location also shows high number of families, which means that they can travel by their car, get groceries. So this is the apt location. All these kind of finding patterns, insights is done by data scientists so that a decision can be made. This is analytics. You are analyzing it based on different features, okay? And you convert it into decision making terms, and which one to be picked depends on your CEO. Okay, such kind of process is called as analytics. Now, they might be doing this. They come back to data analysts saying that, hey, we need some other city which is similar to Bangalore so that we can compare it, so that Bangalore and this city falls in the same bucket. Whatever trades we are seeing, and some other city where DMART is already there, which is similar to Bangalore, so that we can compare what were the patterns that is there in that particular location where DMART is already there, compare it with the Bangalore location and find the application. So the data scientist might come back to data analyst. Now what does the data analyst do? He goes back to the database, analyzes the data again where DMART is already there, try to bring all those, give it to data scientist. So that is what data analyst analyzes the data, and the analytics part is it analysis is part of analytics as well. Again, you can see the first line, analyze business data. So analysis is again part of analytics, but analytics has more steps than just analyzing. Did I answer, or was it vague?
Yeah,
Still
very
confused.
much. Yeah.
Okay, great.
Okay, one
You are joined with your phone and laptop. Both the mics are on.
Can you hear me?
Yeah. You will have to unmute one of it. I think it's because either your headphones mic is also on, your laptop's mic is on, or you have joined through phone and laptop. Both the mics are on. I could hear you, but there was echoing. Try again. We'll check.
Are you able to hear me?
Yes, better. way better. No echoes. Tell me.
So the question is just exactly we will be fitting. So data engineer or after data
Okay.
analysis
Yeah,
to business analysis.
I can give you the answer. See, what has happened is, see, there are specific jobs that were designed for each of these people. Data engineer is someone who is supposed to just connect, find out how to connect to a data source and get the data. He was never expected to do data analysis. Data analyst is supposed to analyze the initial data, clean the data, give it to data scientist. Data scientist was supposed to do run only models, build only models. Business analyst people are supposed to have business talks with people. Now, as industry has become tried to reduce the, how should I put it, tried to reduce the human, the number of people, tried to reduce the heads that are doing, data scientists have started doing the work of data engineer. Data scientists have started doing the work of data analyst. Data analyst has started doing the work of data engineer. Data engineer also does the work of data scientist. So this has submerged with each other, and this is not something that that was written in some papers, but it happened because of industry. They wanted, they tried doing it. See, ideally, to get this running, you need 4 people, correct? Let's imagine that you're paying each of them 10 lakhs, okay, per annum. So what is the total cost for running this for the entire year? 40 lakhs, correct? Now, what industry started thinking is, hey, why can't I hire a data scientist who knows a bit of data engineering, who knows a bit of data analyst? I'll pay him 20 lakhs. Even then the company is saving 10 lakhs there, correct? So that idea came into the picture and people were ready to do it. As a data scientist, initially I was paid only 10 lakhs. I learned a bit of data engineering and they said that they will pay 10 more lakhs. I learned, I'll get 20 lakhs, right? And what did the company gain there? They just removed the data engineer. Okay. And if they're just removing the data engineer, they might give 15 lakhs and they say 5 lakhs. If they're removing business and if they're removing data analyst, they might offer 20 lakhs because they're saving 20 lakhs. They're saving another 10 lakh even then. Right? So that was something that was deliberately brought into the scene by industry. And that is where you have a confusion. Where do these people sit? Because you go to a company, in my role, I do a bit of data science. I write Python code, but officially I'm a data engineer. They've just added data engineer machine learning. But officially I'm a data engineer, but I do write machine learning models. I do write. There are scenarios where the data engineering team does the data science work as well, in addition to what our data science team also does. And this is something that industry has got, and people are ready because they are getting paid more. And that is why you are not able to draw that clear line between who a data engineer is, or who a data analyst is, who a data scientist is. But theoretically, how it is defined is data engineer is someone who connects to the data sources, gets the data. Data analyst does the initial analysis. Data scientist builds the model on the data. Business analyst converts the findings of the business, converts the findings of data scientist to business terms.
Okay.
Hi, Mary.
That okay, James? Yes, please.
With the data engineer, are you talking about DBS?
Everything comes under data engineering. So say, for example, I'm a data engineer. I act as a DBA for my Oracle database. Okay. I also act as someone who builds the data pipeline to connect to my Snowflake, in the sense, connect to my, let's say, Hadoop data sources. So someone who is managing a Hadoop is not called as a DBA, but is a data engineer. I also manage my DBs as well.
No, in the ERP system, there is like two terminology. You divided this four job role. One is DBA,
Correct.
and rest all goes with the technical person or technical
Correct.
functional person.
See, that's again depends on the organization, right? See, ERP was something that was. I'll give you an example for that. Have you heard about the company called as Musicma? Most of you might have heard. In Musicma, there is a particular role called as decision scientist. And Musicma is the only company has a decision scientist, as far as I know. Everyone else has a data scientist, a data engineer, data analyst. There is no decision scientist. See, that is something that when I joined in my first organization, I was called as a graduate specialist. And I have never heard about a graduate specialist in any other company. My role's name was graduate specialist. So all those system, they have to do some or the other kind of division. And that is why they have done it as DBS and ERP. Earlier there were only databases, and there was there was a requirement of an admin to manage it. So they said that okay, DBA was a special guy. All the other guys, let them fall into technical. Now it has slowly started disappearing because it's not just DBs that is there. You have Hadoop, you have graph DBs. It's not just your structured RDBMS that is there. So people started dissolving those lines. So what the point here is, it's an evolving thing. Okay, so you might see your legacy systems tagging DBS as a separate guy and all other guys as technique. It's a legacy system. As and when it goes forward, and again, the definition of your data engineer, data analyst, data scientist, business analyst that I have shown here is also something that is from the legacy. But it has started to fade away. It's no more there. You might see a opening in a company, the role's name might be business analyst, but you might be even you might be asked to understand write SQL queries. Ideally, a business analyst need not know how to write SQL queries earlier, but with more people learning SQL, more people skilling on horizontal level, it has become a demand that a business analyst should know SQL. A business analyst should know a bit of machine learning understanding, etc. So what I'm trying to say here is it's evolving. You might see different divisions or different categorization in different ERP systems in different companies. It's all because companies started forgetting that we have to follow the legacy. They feel that, hey, this is what is needed right now, and I am okay. I don't want. I'm okay with people saying that the business analyst job over there is not actually a business analyst job. It's okay for the company. I am ready to pay him more and he's willing to do that job. Then why? What is the problem? That is the thought process that is going on right now, which is kind of good in a way because you get paid more if you have more skills. But again, it's kind of bad also because it doesn't give a clear cut boundary on what is being expected from a role. Today, a data scientist might be expected to do so and so job. Tomorrow, maybe he might be expected to talk to the CEO as well, which is kind of encroaching into what business analysts were supposed to do. So the good thing is, if you know how to make stories and convert it into business terms, there are companies who are ready to pay you more. But the bad thing is, tomorrow the company will put more demands onto you, asking that I'll give you 2 more lakhs. Can you do this? And then when one starts doing it, others follow, and then it becomes a prerequisite to become a business analyst. Okay. Are we all good?
Well, Ganesh here. I have a question.
Just one
you
more
can
question.
choose to answer later. Okay, so in the previous slides, you spoke about security and integrity. And now we are talking about what are the different stage of processing the data and analysis.
Correct.
Where do we handle whether the data is true? I mean, what is the equivalent of a truth here? Because people can forge, people can fake, and like they say, garbage in, garbage out. Right?
Correct.
So
Right.
at which stage do we really handle it as part of the data science anywhere, or
data processing? Definitely data processing part. It's into data processing part. I'll tell you an example. Again, I'm trying to connect it with big data. You might have heard about big data having 3 V's and all, right? The volume, velocity, all those things, variety, right? Then industry started adding more V's, and one of the V that they added was veracity, whether I can trust my data. Okay, so that trust part actually is done by, to a certain extent, by data engineer, followed by data analyst. Post that, there is no trusting. I mean, the data that the data analyst gives to the data scientist should be trustworthy data. So it's the job of data analyst and data engineer together to find the trusted data. Now, how can I do that? I'll give you a simple example. Okay. There was a recent project that we did, which is customer hierarchy cleanup. What does that, what we are trying to do is, our company has a lot of customers. Okay. And customer, let's say, for example, can I give a simple example? IBM. IBM is a customer. Okay. And Red Hat is also a customer. Okay. Now, 5 years back, IBM was a single company. Red Hat is another company. Now, what happened is IBM acquired Red Hat. It should have been shown in our database, but we didn't show it because we were not worried about all this until we realized that a subsidiary relation helps you to grow the business. So we should identify which company is a subsidiary of which company, how many such subsidiary is there, what is the relation between these subsidiaries, whether this particular subsidiary that is similar to another subsidiary has bought so and so product which is not bought by the other, etc. So you get that, right? There are a lot of use cases when you try to bring subsidiaries into picture, but our customer hierarchy was not properly done. Now, one source to find out whether a company is a subsidiary of another company is Wikipedia data, right? Now, can you rely on Wikipedia alone? No, because Wikipedia is something that can be edited by anyone, correct? So it is not the complete truth that is there in Wikipedia. So as a data engineer, what I did is I first connected to Wikipedia. Then I connected with Dan and Bradstreet, which has all this acquisition and mergers data. DNB, I connected to DNB, I connected to Wikipedia. I brought in all this and I gave it to my data analyst. What he did is he compared the DNB data, DNB here meaning Dan and Bradstreet data, and then he also looked into the Wikipedia data. And he took all those where in both places it was the same, it was correct. And then he told that, hey, this is trusted data. He gave it to the data scientist. Understood where the trustworthiness of the data comes in. It's done by the data analyst and the data engineer together. Data analyst say, I just connected to Wikipedia, I gave the data to data analyst. It might not be right completely. So the data analyst would come back and tell to me, hey, taking it from Wikipedia alone is not correct. Let's connect to DNB, get that data as well. So I become a part of that involuntarily. And the check is done by data analyst. Whatever that data analyst theoretically, whatever that again, in quotes, theoretically, what the data analyst gives to the data scientist should be data that is trustworthy, that is accurate, that is reliable.
Thanks, Merin. This helps.
Thank you. Any other questions?
Yeah, just one question.
Yes, please.
Okay, so it's a continuation of that, all the four different types of people. And if one person know every bit of single thing, then what is the quality of the things? If I know everything, then I cannot do the perfect things or expert
Correct.
work in data engineer.
Correct.
Might be I'm in BA, but if
Yes,
I have to
and
know everything,
you are exactly where the industry is moving towards right now. So there was a phase when people thought becoming jack of all trades is good thing. Okay, now people or industry have started realizing that, hey, I don't need generalist, I need a specialist rather than a generalist. There was a time period when companies thought a generalist would make more sense than a specialist because a specialist knows only one thing, whereas generalist can be used for different things. Then, as you exactly pointed out, people started figuring out, people in the sense of companies started figuring out whatever that is generalist, some of the generalists are producing quality products, but not every generalist. If I have to ensure quality product, then I have to bring in specialist. And that is why you see a boom in people going for MS, MTech, etc. All the working professionals are going for MS, MTech. Earlier, a BTech was enough. Now people started realizing that, hey, my company is specially looking for someone. The industry is trying to move towards that direction. Are you getting? So um, the lines that are blurred might come back in future. The data engineer line, the distinguish between how to distinguish between data engineer and data analyst is right now kind of blurred, but it might come back in coming few years because industry has realized that it's more specialist people that we need. Someone who knows very deep about one thing would definitely produce a quality product about that rather than someone who knows everything, something about everything without producing a quality product. So right, exact to your point, industry is moving towards that. And again, it's very evident, right? You see a lot of uh, online platforms coming with different kind of specialization courses. Why? Because they have realized that the education industry has realized that there is this thought that is coming into the picture, which is we need more specialists rather than generalists. Let's cater more MS courses. Let's cater more PGDP courses, postgraduate diploma certificate courses in giving specializations so that they become specialized in a certain skill. You are right. I mean, the answer to your question is you are right. The quality is going down, and that is why people think that more specialists are needed. And again, that is one major reason that uh, uh, in addition to data science MS, I'm also concentrating more on AI and ML because I see that there is a scope for AI and ML, and I'm also doing an MS in AI and ML, which because in addition to data science is a broad thing. I felt that I should concentrate more on AI ML, and so I'm taking an MS there also. So I started realizing it. My manager started telling me, hey, we need more specialists. So there is a scope for AI and ML in our team. Let's you concentrate on that. And based on his suggestion, I started doing MS in AI and ML as well.
Okay, thank you, sir.
Yeah, Guru here. I think it is also based on the evolution. See, maybe
Correct.
I think at the beginning there will not be much of the clarity, but whereas I think once we get somebody gets into that, there will be a lot of clarity and volume of work. So that is where it demands the specialists.
Exactly. Exactly. You're right.
Uh,
Only when more
Let me
people
interject.
start doing it, people think that, oh, there is a demand there. And back in 2013, I don't think there was a term, I mean, or data scientist term was this common, right? Now 2014, 15, 2016, 17, now everyone wants a data scientist, correct? So similarly, now you have not heard about much about AI engineers, right? Not every company has an AI engineer. There are companies who has AI engineers. That was the case back in 2013 also. You had companies where you had someone called as data scientist, but not every company had it. Now every company has data scientist. Moving forward, maybe in 2025, 26 or 30, every company might have an AI engineer. And then another thing would come in and people will start following that. So this evolution is always good, and that's why it's called as evolution. It happens every time, it keeps on going. Yes, there was one more question. Sorry to cut down. Someone was going to ask me a question, right?
Not question. I was trying to answer that question. Manjunath here.
Please.
Yeah, both the question. Earlier, someone asked on security check, right? In our company, we do something called a DQ check, data quality check. It is DQ check is basically a responsibility of both data engineering as well as data scientist. But this is a process till end of project. It keeps going on based on the business decisions in between whatever we take. It keeps growing, but finally, after a lot of discussions, once DQ check is ready, it will be done in deployment stage before as well as once it is deployed after, and also during retrainings and all. So it is not like completely defined as you answered. It is same, like it is a collaboration work more than defining a boundary there. All teams are involved, and mainly sometimes even the higher management gets involved because some decisions, right? Like for example, if I want to decide, like I have to give this value based on business rule, not based on my model or not based on the data available. So those things are also embedded in DQ checks.
Correct. I can't agree more. I mean, I totally agree with it. And that is why I was trying to stress on that particular word. Theoretically, it was supposed to be done by data analyst, but now it is a collaborative work because there
Yes,
are
it
many
is
things that a data analyst might miss, which the data scientist might find out, which again, there might be certain things that the data scientist might miss, which is coming from the upper management. So it's a collaborative work. Theoretically, it was supposed to be by data analyst. Again, theoretically, not at all practically. It's a collaborative
And
work. I
for
mean,
the
I
second
totally.
question, right, the roles exact definition. Actually, it depends on the company also. I have been through both of these companies. Like in some company, like where it is like startup kind of environment, right, where we are developing a POC. There are no established teams. So at the end, it is the solution matters. What you are delivering as a solution. If require, you need to like data is not available means there might not be a data engineering team at all. So it is your job to get that data, do
Yeah,
everything, do a POC. So you are actually wearing the hat of everyone there. And
everyone, and
finally,
you are
the
getting paid more for that as well.
yeah, paid and also the what matters is what you are delivering to the customer at the end. Like business
Mhm.
problem, it may contain anything, but
Yeah,
there are companies well established in AI data science where they have a lot of problems, where they already know the importance of segregating it and going in a collaborative way. Like a data engineering is separate data, so it is left to us to decide where we want to position. That is also again evolving based on experience. It comes like where we need to position ourselves.
agree. I mean, so to add to what Manjunath was saying, 2 3 years back, I thought I should position myself as a data scientist who knows data engineering. That was what I was thinking. And now it has changed. My philosophy has changed. My tenet has changed. I think I should position myself as a data scientist specialized in AI and ML. Again, data scientists can be specialized in different things, right? I'm specifically looking for AI and ML in neural networks. Again, in AI ML, I'm looking for neural networks. So that is, again, to add to his point, that is totally up to us where we want to position ourselves. 2 years back, my concept was totally different. I wanted to convince another organization or any organization that comes to me that, hey, I am someone who knows both data engineering and data scientist. So if you take me, it's good for you, right? But again, now I've changed that. I've realized that no, it doesn't make sense to put hands in everything. You have to concentrate on one thing, become a good resource who produces quality product there. I mean, again, it's my thought. Everyone has different thoughts. So ultimately, it boils down to what you think and what you want to become. I sounded more philosophical than MTech, right? Anyway, so I guess we can safely. I can safely say that this session can be closed, right? So will there are no are there any more questions regarding whatever we have learned right now? Cool. Okay. So we'll take a 10 minutes drinks break. I'll get some water. You also get some water, and then we'll have the next topic. The next topic is ERD, entity relationship diagram. Okay. Before that, there are certain things that we have to learn. What are the different types of models? What are different? What is a data model? What are the different types of data models? And then we go to ERD. From there, we go to relational model. Why we are concentrating on ERD, relational model, etc. Because we are concentrating on structured data. That is the reason. Okay. Good. So just have a 10 minutes break. We'll come around maybe 11:45. I know it's not 10 minutes, but 11:45. Okay. Uh, I think we can get started. I know the breaks are too short, but we do have a tight schedule, and that's the reason. And since it's online, I mean, you can have your breaks. I mean, you can have your food and have drinks in between as well, right? So I hope it's okay for all. So let me just start sharing again. Okay, so up next, what we are going to learn is ERD. Before that, we should understand certain things like what is data model, what is the use of it, what are the different types of data models. So I hope everyone is back. I'm just getting started. So data model, it pretty much gives you an idea about after you are designing something, how does the final system look like? And you will understand this more as we understand more about ERD and relational model, and then you as you try to implement it, you will understand this more. Okay, so data model gives you an idea of how the final system looks. It defines the relationship between different data elements and what are the data elements. There are different, you can define different data elements and the relationship between these data elements. No, don't worry about all these terms. As and when you learn the ERD model, you will be able to connect back to what we are discussing right now. It again, data model helps you to show how data is stored, connected, accessed, and updated, etc. And it every data model uses a set of symbols and text to represent the that information about how the system will look like. Okay, so data model is nothing but a graphical representation that helps you to understand what are the different data elements, how what is the relationship, how they are stored, what is the data type, etc., and how the entire final system would look like. There are different data models starting from hierarchy model, network model, entity relationship model, relation model, flat data model, etc., etc., etc. There are so many. Each of it has its own benefits based on the use case. Each of it is different from each other. But since we are concentrating majorly on structured data, the point of interest for us is entity relationship model and relational model. Earlier, uh, 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 we tried to cover this all the different types of data model, but now there's it's only 2 days, so I request you all to research what is hierarchical model, network model, etc. Try to understand it. If there are any queries or doubts, I'm more than happy to help you. But we are not covering that in this particular session. In this session, we are concentrating more on entity relationship model and relational model. What is entity relationship model? You have certain entities and then you have the relationship. Now, ER is a high level data model diagram. ER, entity relationship, is a high level data model diagram. So when you hear, you might have heard as ERD, that is entity relationship diagram. It basically is a diagram. ERD is a diagram that helps you to understand a entity relationship model of a system. Okay, now entities are nothing but real world things. For example, in this in this particular entity relationship model that you see, teacher and department are the entities. Okay, anything that resembles a real world thing is an entity. Okay, attributes are nothing but the properties that entities have. For example, a teacher would have a teacher name, a teacher ID, a salary, age, a phone number, etc. So all these properties of this entity is called as the attributes. Similarly, for department, you have a department ID, you have a department name, you can have a number of people in the department, etc. All those attributes that define department, all those features that help you to define the entity department are called as the attributes of the department, attributes of the entity. Now, tying this to the previous definition of data model, this ERD helps you to understand how a system of teacher and department would look like, right? It helps you to understand if you're trying to implement a system where there is a teacher and department, this is how it would look like. A teacher would work for a department, a teacher will have teacher ID, etc., etc. And so that is what is told. It gives an idea how the final system. It defines the data element. The data element here is the entities, the attributes, etc. are the data elements. How they are related is shown through works for. How this teacher entity is related to department. A teacher works for a department. How it is related. How the data has different features. How can it be updated? How can it be accessed? All this can be deducted from this picture, right? This is what is called as ER diagram or entity relationship model, where you have entities, you have attributes, you have relationships, which tells you how two attributes or two entities are related. It's a graphical representation for better understanding of what this system is. And it is easy to convert to any model. If you have an entity relationship model, you can convert it to a hierarchical model if it's needed. You can convert it to a relational model if it's needed. You can convert it to a network model. All those. It's easy to convert to any model. And here we are specifically looking into the conversion of ERD into relational model. We'll come to that after we understand what relation model is. Now there is no industry standard notations in ER, but there are certain notations that we follow, but it's not industry standard. But there is a general consensus on what should be concise, on what should be followed. We'll see that in the coming slides as well. One major drawback about entity relationship model is that some information we might not be able to represent certain information in the ER model. Say for example, the teacher ID. It has to be a number or it has to be a certain data type. The data types of these attributes are not mentioned here. It's missing. The constraints that has to be put on these attributes are missing here. Like mobile number. The mobile number has to have 10 digits and it should be digits. That constraint is missing in this ER model. Age. To become a teacher, he or she should be so much minimum age should be there, etc. So all those things are missing in this ER model, and that is why we have written it as some information might be lost or hidden in the ER model. Three things. First one, entity. Second one, attribute. Third one, relationship. Three things to remember: entity, relationship, and attributes. Entity represents a real world thing. The qualities or features of that real world thing comes in as the attribute. How two entities are connected to each other gives you the relationship. Next model that we are going to look into is a relational model. Relational model. Yes, please.
So can I have some examples of ERN?
We are going to actually develop a ER diagram. Moving in the coming hours, what we are going to do is we are going to understand a real world example, have some data points from their build an ER model. From that ER model, develop a ER diagram. From that ER diagram, you will convert it into a relational model, then implement that relational model. This is what we are going to do. Okay.
I have just one objection here. So
yes.
I am working on one of the ER model. It's called Microsoft Entity Framework. I'm working on the latest one. I think 6.0 it is. And what I can see there, as you mentioned, it is mapping between the database and your application. I see. Honestly speaking, I think always in practical. I mean, this thing it's okay, but I like to realize things in a practical manner, in the real world application. how it will be. So in this case, if you see entity relationship model like in the entity framework, so we can have again, like it is a mapping between the database and your code or your application, and it can be either code first approach or database first approach. So either you write your own, either you design your model first, then it will create the tables, etc. of the things, or you first have database, then accordingly you update your entity model. Now the problem here, as you are mentioning, there I can see whatever your types are there, like department ID here, and here in your class, here it is teacher. If I, okay, I don't know which one is fitting on the code side and which on the database side here, representing which one. But thing is that here the types and all the last statement, no, what you are mentioning, some information lost. I don't see that. I mean, it is all the information are same to same. Whatever I am having in it, even a small change in data or data type, etc., it will throw an error. I'm practical way. I'm just trying to imagine. So how you are saying that it is not there present or missing or here middle?
See, you are using, okay, so I'll try to answer this way. You're using a tool to develop the ER diagram, correct? And so we will also, so there are two, so in the practicals that we are going to do, we will also develop ER diagram in two ways. Okay, the first one is your MySQL creating an ER diagram for you based on the table structure and the relationship that you have mentioned, and you get an ER diagram automatically created by MySQL. And the other one is you draw a ER diagram based on what is the business understanding is. Okay, now if it is a tool that is used, obviously your errors would be pointed out. Now, theoretically, ER model is something like this. What you see here. This is what an entity relationship model is. OK, I understand what you're saying in your practicals where you have your tools to develop it. It's a total different story is what you're saying. That is because it has evolved over a period of time. Now, entity relationship model is something that you see here like this. And why this point of some information is might be lost or hidden is giving you this entity relationship model and asking you, do I have a constraint on mobile number? It's not mentioned here, correct? The department could have an HOD. It's not mentioned here. So there can be data that can be lost, that can be missing or hidden. That is what it's meant. I don't know if I am able to. So your ER model is like this. Forget about what the tool develops, or that's a different story, because you have put certain constraints in the tool which helps you to identify that there is an error.
And what is the application scenario here for this ER model when this key data are missing?
Correct. So what happens typically is when you are, and this is what we are going to do in our practical application as well, you are going to get certain data points, certain metrics. OK, and it will be given to you telling that, hey, so and so metrics have been collected. First thing that you do is you build an ER diagram out of it so that it can be easily represented to people, and you can tell them that, hey, so there is this particular attribute, there is this particular entity which has so and so features, there is another entity which has so and so features, and these two are related so and so. OK, you first create this ER diagram so that you can graphically represent what data points and what are the features it has for easy understanding. The major idea is here graphical representation for better understanding. You can easily do that by looking into an Excel sheet also. That is also possible, but this makes it more easier to convey the message. Now, once this entity relationship model is built, you can convert this into a relational model. Relational model stands as the base for your RDBMS. You convert that relational model into tables and the different foreign key, primary key constraints. So the order, the logical order that follows is first you have the data points, you make an ER diagram out of it, you convert it into a relational model, and then you implement that relational model into a DBMS. And that is how it's been applied in the industry. All good?
Yeah, good sir.
You said first you create a data link, sorry, data point, and then you create a hierarchical data sets, and
No
then
hierarchical.
you
No, so hierarchical. No, so I'll give you. I'll just share.
relationship model, yeah, or something, right?
Correct. Entity relationship model. Correct.
Yeah.
We create an entity. So say for example, in the use case that we are going to work upon is a telecom churn data. Okay. So what is the first thing that we are going to get is we'll get a set of data points like what is the customer ID, what is how many dependents are there, did they churn or not, what is their total charge, etc. So you get all these data points. Now what you do is you create an entity relationship model out of it, telling that, hey, customer is one entity who has so and so attributes. Okay, there is another entity which is customer account, which gives you so and so details about the customer's account. There is another entity which gives you so and so details about another entity. So you build that entities out of it, bring in all the attributes, and then you say that it's related. They are related. Okay. Then you
Yeah.
convert it into a relational model. Now, what is happening these days is people skip this entity relationship model. Ideally, the logical path would be create an ER model, convert it into a relational model, and implement it. Now, in most of the cases, what people do is they directly go to relational model because this is kind of already known in your relational model. You can easily deduct this from relational model that this is what the attributes is. You look into a table, you look into customer table, and you know what are the attributes of the customer ID, the customer name, the customer address. Why should I draw like this is another question. So people usually have a tendency to skip it, and we can also skip it. We are also going to skip it, but this was the actual first step. Okay, so entity relationship model, you can build the relational model out of it. So how does the relation model would look is, it is nothing but a table. Now you see this employee table, right? You can easily identify what are the attributes of employee table. Employee ID, employee name, job name, salary, mobile number, department ID, project ID. You could draw a ER diagram out of this, right? The first box would be employee. Then you have all the IDs. Now, if you can show that picture to someone and it is easier for you to explain, telling that employee is an entity, it has the attributes. You can also explain by showing it as a table, but then people tend to remember more using pictures rather than tables. That is the only difference. It's the same thing that you're doing with both the models. You are representing almost the same thing, but relational model has bit more benefits, like you can add constraints, you can show which is the primary key, etc. That makes it different from ER model. ER model doesn't have all those details. You can't, if in relational model, you don't know which is the primary key, you have to add it, etc. All those things are to be there, whereas in relational model you can define it, the foreign key, the primary key. You again, I request you to be patient, because as and when we start doing the practicals, it will make more sense. Both are different ways of doing the same thing. Initially, people used to develop an ERD first, convert it into a relational model, implement it. We became more intelligent. We realized that there is no need for ERD. I can understand it directly from relational model. So I'll go directly to relational model, build it, implement it. That's what is happening right now. You won't see this ER diagram anymore in use, not anymore that frequently in use as it was previously. But you will see this relational model everywhere. Entity relational diagrams would be there. Okay. Now your entity relational diagram contains a mix of, nowadays what is happening is the entity relational diagram is a mix of relational model and ER model. So say for example, or when we do it, I'll show it. You will have table structures connected to another table structure with how many, what is the relationship type, etc. That is what you see as the ER diagram right now. behind the scene, it comprises actually two things. One is the entity relationship model and the other one is relation model. People have started combining these two together and they are showing it as ER diagram. Again, the same thing I said before, just hold on. As and when we start doing the exercise, it will be more clear.
Yes.
To add to what I have been telling, relational model is nothing but it's mentioned, it is maintained in the form of two-dimensional table, which is nothing but rows and columns. The basic structure of a relational model is also called as relation. Each table that we see in DB is called as a relation in relational model. Each row is called as a tuple, and each attribute is nothing but the column. So this is your attributes. This is your tuple. All together, this is called as the relation. Then it has structural independence, can make changes in database structure without changing the way to access the data. All these are benefits. You don't have to by heart or know it. Just understand that there are benefits and there are downsides to it. It's very easy to design without knowing what is the background or what is the constraints that should be put in, which might result in bad DB designs. Now, next is where you will start to understand the ER model and the diagram. So we saw an example, and this is a more detailed example. Entity is employee. Department is also an entity. Your relationship is works for. This is your relationship. Employee has attribute gender, designation, employee ID, department ID, etc. Your relationship works for also can have attributes like whether it's a shift working mode or a remote working mode, on shift basis or remote working mode, etc. Your department has different attributes like org, HOD, department name, department ID, etc. So a typical ER model looks like this. Now, we go further, we should understand the different type of attributes. We saw that attributes here like gender, designation, employee ID, department ID, etc. Let's try to understand what are the different types of attributes. First one is symbol attribute, which is nothing but you cannot divide it further. Example is gender. You have male, you have female, you have transgender, you have all those things. You can't further divide it. OK, next one is the symbol. Next one is the composite attributes, which can be further divided. For example, full name. It can be further divided into first name, middle name, last name. So a single attribute can be further divided into multiple attributes. Then
Hello?
that attribute is called as, yes, please.
I think your screen is still not refreshed.
Is it the same for all?
We are
Yes,
We are
still
seeing
ERD.
entity ER slide
So
only.
I'll just, sorry, I'll just reshare again. How about now?
Yeah, it's good.
Yeah.
Again once more. So symbol attribute, attributes which cannot be further divided. You cannot be further divided. Sorry, I missed a D there. Example is gender. As I told, male, female, transgender, etc. You can't further divide it. Whereas composite attribute is where you can further divide that attribute. An example is full name. If full name is an attribute, you can further divide it into first name, middle name, last name, etc. Then you have single valued attributes, can have only one value. Example, it can be either male, it can be either female, it can be either transgender, etc. Whereas multi-valued is, example is contact number. You can have multiple SIMs, right? You can have two phone numbers. So that is an example of multi-valued attribute. Next one is a stored attribute, which is nothing but it can store a value only. For example, year of birth. You can't change it. You can't have multiple values to it. Your year of birth stores a value and that is permanent. There is no change to it. Correct? Such attributes are called stored attributes. Last one is derived attributes, which is you can derive an attribute from a stored attribute. For example, from the stored attribute year of birth, you can derive age by doing a minus of the current year and the year of birth. So such attributes which can be derived from another attribute is called as derived attributes, which can only store value which doesn't change at all is called as year of birth. If there are multiple values, I mean, all the names itself are kind of self-explanatory. Symbol, it's symbol, you can divide it. Composite, there are multiple things in it, you can divide it. Single valued, only one value can be expected. Multi-valued, you can have multiple values. Stored, it's a stored thing, you can't change it. There's no change that is going to happen. Derived, you derive it from the stored attribute. There is one last one, which is a complex attribute, which is if you have both composite and multi-valued together, it's called as a complex attribute. For example, address. OK, most of you might be staying in your hometown right now, right? And your work location might be in Bangalore. You might be having an apartment there as well. Now, when you were ordering things from Amazon, your address would have been back when you were in Bangalore, your address would have been Bangalore address. And if you when you are ordering now, your address might be your hometown address, correct? Now, when you are ordering, you would see the last page of the ordering process where you are given the option for selecting which address to be sent, correct? That is what is multi-valued, correct? Address can be multi-valued. Now, how does it become a composite? Your address has a street, your address has a lane number, your address has an apartment number. This can be further divided into different attributes. Apartment number is one attribute, street is another attribute, your pin code is another attribute. All this come together as an address, correct? And that is why hence it is called as complex attributes, where you have both composite and multi-valued coming in together. Okay, give it just an example, address. Okay. Next one is relationships. There is something called as degree of relationship. Degree of relationship means the number of entities participating in a relationship. So for example, here you see employee and department with the relationship works for. How many entities are connected to the relationship works for? 2. That is what is called as the degree of relationship. So for the degree of relationship of works for relationship is 2. You can have degree of relationship 1, a degree of relationship 2 or more. Okay, you can have multiple relationships. Okay. Now, next term that you have to remember here is cardinality and modality. Cardinality means the maximum number of associations between a table, whereas modality is the minimum number of association between the tables. Now, what that means is employee is related to department. Okay. Cardinality means how many departments to which an employee can be associated with. What is the maximum number of departments to which an employee from the employee entity can be related to is called as the cardinality. Whereas what is the minimum number of association that an entity has with another entity is called as the modality. In this example, how many minimum departments, what is the minimum number of departments to which an employee can be associated is called as the modality. Cardinality is the maximum number to which it can be associated. Modality is the minimum number to which it can be associated. Now here, if you see here, it's 1. What does that mean? An employee works for only one department. Okay, now this is your cardinality. It says that an employee can at most work for a maximum of one department. Modality will we'll see how modality and cardinality is represented together in the coming slides. Clear with what cardinality and modality is? Now another example is student and course. Okay, a student can be associated to a maximum of 5 courses from a department, which means that in a given department's course, a student can take only maximum 5 courses. And a student can have a modality of 1 course or 0 course. It means that a student, if I say a student course relationship has a modality of 1 and a cardinality of 3, It means that a student can enroll for maximum 3 courses and he should enroll for at least 1 course. Clear? That is cardinality and modality. All good? There is another concept called as total participation and partial participation. What does it mean is based on the minimum number of relationships that an entity can participate in, it can be divided into total participation or partial participation. Now, total participation is represented by 2 lines. What it means is if every entity in the employee participates at least once in this particular relationship, it is called as total participation, which means that in your employee, if there is no employee who is not at all associated with any of the department, then employee entity is considered to be in total participation with department. If there is no employee who is not associated with any of the departments, then the employee entity is considered to be in total participation for the relation works for. Similarly, from the other side, if there is no department that has no employees at all, then you will say that department is in a total relationship with a total relationship in this works for relationship. It is represented by 2 lines. Total participation. If you see 2 lines in your ER model, then it means that whatever that is there, all the employees are associated to at least one department. There is no employee who is not tagged to any department. That is what total participation is. Next one is the partial participation, and partial participation is shown like this. What it means is there can be a department who has no employees in it, which means that that department is not taking part in this relationship. So from the point of view of department entity, not every department is taking part in this works for relation, and hence there is only partial participation of department in this relation. It's usually represented by a single line. All good. And again, another example that another way to understand this is your employee has employee 1, 2, and 3. Employee 1 and employee 2 belongs to department. Employee 3 belongs to department 3. No employees are there who are not associated with any of the departments. All the employees are associated one or the other department. Hence, employee is in a total participation in works for relationship. Whereas department D2 doesn't have an employee and hence department is in partial participation. This is one way of showing in ER model. Okay. Now you can also show this in your ER diagram using cardinality and modality. We will see that in the next coming slides. And that way of representing is called as the crow's-foot notation. What crow's-foot notation is a bunch of symbols that helps you to understand what is the cardinality and what is the modality between two tables in two relations in a relation model. Okay, two relations in a relation model. These relations are nothing but tables. Now, if you see just a single line, it means that it's one relation. If you see 3 lines, it means that many. And if you see a 0, it means that it's 0 relation. Now, this is what the symbols mean. Now let's see when how do you represent modality and cardinality together? The first thing that you see here is the modality. And the next thing that you see is the cardinality, which means this represents the minimum number of relations and this represents the maximum number. This symbol is called as 0 or many. It means that an entity can have no relation or can have many relationship with the other entity. So to represent that, you have this one 0 many. Next one is 0 or 1. Next one is 1 and only 1. Both your cardinality and modality is 1, which means that the minimum number of relation and the maximum number is 1. You can't have more than that. That is why it is 1 and only 1. The last one is, sorry, this is 1 or many. One or many. Now, let's see. Sorry. Can you come again? Was that a doubt?
PPT is not.
Oh God, what is happening? Give me a second. How about now?
Yes.
I hope it was visible up till this point. Right? Okay, so one or many means one or many. Now, let's try to see this relationships mentioned in your relationship model or ER model using cardinality. Now, what does this mean? Many to many. Your employee. Now, when you are talking about this entity, employee, its relationship is defined here. OK, always go to the other entity to find the relationship. When you're talking about department, what you see here is the relationship. OK, now employee, many relationship to department. What does that mean? An employee can be part of multiple departments. Similarly, a department can also have multiple employees. That is how you read it. OK, an employee can be part of, can work for multiple departments. A department can have multiple employees. Since it's many here, it's called as many to many. This is just representation using cardinality. We'll take it step by step. OK, first you will understand cardinality and then I'll add modality to it and then we'll rephrase it. Now, if it's many to 1, what is the change that should happen? It should be many here, and instead of many here, you will have 1. How do you say it in English? An employee can be part of only one department, whereas a department can have multiple employees. While you express the relationship, it is this, it's from left to right. The entity that you take, if you want to find its relationship with the other entity, you have to check for the symbol that is there at the other end of the entity. So if you're taking employee, if you want to know what is its relationship with department, come to the department end and then you see the symbol that gives you what is the relationship of employee with department. An employee can be part of only one department, whereas a department can have many employees. And you will represent this as, or you say that works for has many to one. Works for has many to one relationship. 1 to 1. Again, now it's becoming more obvious, right? How to read it? An employee can be part of only one department and a department can have only one employee. 1 to 1. Next one is a special kind of one which is called as recursive. OK, recursive means if an entity is related to itself, then it's called as a recursive relation. Now, an employee's manager is also another employee who comes in the employee entity. That is recursive. An employee's manager is also another employee who comes in the employee entity. Such kind of relationships are called as recursive relationship. It's a special kind of relationship. Now, we saw how it is working with cardinality. Now, let's add modality to it. What does this mean? Employee, the relationship obviously now you can tell what the relationship is. You look to this side. It says many, one, two, one and only one. Correct? Many, one, two, one and only. Many, one, two, one and only one. Now let's try to tell it. What does this mean? An employee can be part of one and only one department. Your cardinality is this one. One, your modality is this one. Minimum, maximum. Minimum one, maximum one. One and only one. An employee can be part of one and only one department. A department can have, what is this? This is your, so when you are looking from this side, what is the first thing that comes? Modality. Then you have cardinality. A department should have at least one employee and can have many employees. A department should have at least one employee and can have many employees. Many, one, to one and only one. Clear? If you are able to read one, then everything else can be read easily. This again, the relationship would be many, one, to many, one. Many, one, to many, one. When you say the relationship, it's usually cardinality first, modality second. When you read, when you tell it as a sentence, usually modality comes first and then cardinality comes. Okay, so what is this? Many, one, to many, one. What does this mean? An employee has to be part of at least one department and can be part of many departments. At least one department or many departments. A department has to have at least one employee or it can have many employees. That is what many, one to many one is. Again, many, 0, 1 to 1. Many, 0 to 1 and only 1. What does this mean? An employee can be part of one and only one department, and a department can have 0 or many employees. There can be a department that doesn't have an employee at all, and a department can have n number of employees. But an employee can be part of only one department, one and only one department. How is it represented? Like this. Next one is 1 to 1, 1 and only 1 to 1 and only 1. 1 and only 1 to 1 and only 1. What does this mean? A student can have a minimum of one chair and has a maximum of one chair, which means that he can have only one and only one chair, one seat. And a seat is also allocated for one and only one student. This is one and only one to one and only one relationship. One is many, 0 to 0, many. Many, 0 to many, 0. What does this mean? A student can enroll for no courses or many courses. A course can have 0 students or many students. There are different combinations of this. You can do all this, but you get the basic idea of how to read it, right? When you are reading, whichever entity that you're picking, its relationship with the other entity comes along with the other entity. First thing, maximum, then you have minimum. It's from the point of view of the entity. When you are taking department, the point of view starts from here. The first one is the minimum and then you have the maximum. Here, this is the minimum, this is the maximum. Okay.
So
Many one.
question.
Sorry, go ahead. Yes.
Yeah, I mean here. So considering the modeling part and the relation part, right? Like just an example here, if suppose I have a data set, all right, and then in that data set, I have a column, and just let's name it as XID column, which is completely unique, or a unique value, right? That ID column is linked with another column which has four unique values in it. So let's imagine here it's one to many relationship in a data set in those two columns, right? And then we have different attributes or columns which are numerical columns, right? Okay. And when we try to unpivot this data set, right, the unique column which we had at the beginning, it becomes a duplicate, right? Because each line will be associated to those three attributes in the second column, right? So it becomes duplicate. And when we do that thing, the entire size of your data shoots up, right? And then how would we model this relationship here, sir?
Correct.
Because even if I try to take a dimension table or any other create a unique table, it'll always have that one to many or many to one. It won't have that relationship of one to one connection there. How would you model that, sir?
That is where you bring in the concept of normalizations. Okay, it's more of a data warehouse concept, which is where you have one normal form, two normal form, three normal form, BCNF, etc. Where you try to avoid data redundancy, you try to avoid multi-valued attributes, you try to avoid composite attributes, etc. So it's a totally different concept and implementation. What you do is you build a relational model and then you try to normalize it so that it doesn't have duplicate values. That is called normalization. It's a different topic, but this is the idea. Yeah.
What we can't normalize that relationship, sir? Because each of that entity there, each of the value which we are talking about, has a particular use in it.
You answered it. You answered it. If it can't be normalized, you can't do anything.
Then
It
how
has
would you have that relationship there, right? Because even if we have that relationship, it tends to it basically eventually the concept, yeah, I'm talking about that concept, it comes into different categories, but eventually the size increases, right? And then how would we handle that relationship there
See,
in
again,
terms of relational
that's
cardinality and stuff? Yeah.
yeah. Is there anything? Was someone else also talking? No, right? Okay. So, um, uh, see, there is something called as OLTP and OLAP. Okay. OLTP is for online transactional processing and OLAP is online analytical processing. Now, whatever that you are saying right now is something that comes under OLAP. Okay, which means you have data duplicates, there is the size of the data is going to be huge, but it's okay because you are doing an analysis. There is nothing to update, there is nothing to do, etc. So those where you can't normalize it, people keep it as it is. Now, how do you define a relationship? There is no relationship that can be defined there. Why? Because it's all in a single table, right? You only have one entity. Say, for example, you if you combine your employee and department together, okay, let's say that there is a single table. Now, with the concept of what I'm showing here, when this gets converted to relational model, this will be two different tables. Employee would be one table, department would be another table. Let's say that you combined employee and department data together. There will be data redundancy, right? Because an employee, there might be 5 employees who are part of HR department. The details about HR department will be repeated multiple times, correct? HR department, who is the HOD, who is the director of HR department, where is the HR department sitting, etc. All these would get repeated for all the 5 employees. That is what data redundancy is, correct? That is what you are trying to say here also, right?
Yeah.
So in such cases, it's only one table that you have. So you can't define anything there. There is no relationship. When does relationship come into picture? When there are two entities, when there are two tables, you are trying to say that table A is related with table B like this, with many to many or many to one, etc. Now, when you have it as a single table, there is only a single entity. It doesn't have to show any relationship. There is no other entity to show relationship to. Now, what you are asking is, how can you represent the relationship between the attributes of the table? We do not do that. Right? There is employee ID column and there is department ID column. One employee is related to one department ID. Another employee is also related to that department ID. It's two attributes of the single table. Okay, we won't represent that. Am I clear?
Can I say in some other way? Like in the database,
Yes.
we have like employee table and department table. If we search the employee table, then what mapping is defined based on that, we will get the department. Like we are searching for employee ABC. Based on whatever, if we have ABC is connected only to one department, then if we query employee table for ABC employee, then we will get one department. If
Correct.
we if the employee is associated with multiple courses, then if we say like search the table employee for ABC, then we will get the multiple courses. Now, if we query the department table, then based on department connection with the employee, we will get the data. So this is how it is represented in the database.
Correct. I agree that. Okay, so was that something that you are trying to add up, or was that a question, or I got confused?
I was just explaining how it looks like in the data.
Great. Then we are good. We are good. I thought I was saying something different. I'm also saying the same thing. I can show you an example with an Excel sheet, maybe.
Sir,
to make.
Sir, can I take Amin's question to the next level? I mean, I understood what Amin is asking. So the relationship between the entities in the table. For example, if we forget about this department table, seat codes, all these things. For example, you have this in the employee table, and in this employee table itself, there could be a relationship possible where, Amin is my manager. Okay, so Amin is also there, and also I am also there in that table. But how to represent that relationship in the table? What form? How can we represent that? That's what I think he's asking.
Recursive. That is where you have the recursive. And you can put a number here. An employee is managed by N. So I have not added here. You can add 1, 2.
I can explain how it goes in the database. Employee will have an employee ID. So you will have employee ID and Amin will also have an employee ID. Then you will have one more column, supervisor ID. So in your record, the supervisor ID will be Amin's employee ID.
Okay, you got a table, you don't have supervisor data actually.
We will not have a different supervisor table. It's like based on employee table only we can define.
Your employee table is this EMP ID. Okay, then you have your EMP name, then maybe your department ID, and then your manager ID. Okay, let's say 1 Amin HR, your manager ID is 5. 2 Rahul HR, manager ID is 5. 3 Rohit sales, manager ID is 4. Pradeep sales 4. 5. Give me some name. I'm not getting a name. Mary, sorry, not being a self. HR 5. Who is the manager of Amin? Manager ID 5. Mary.
You keeping yourself as manager?
Yes, obviously there will be one who would be like that, right? Who is the manager of a CEO?
Yeah, I understand. No, normally it is put like 0.
0 or anything. I mean, you report to yourself. I mean, I can't keep on writing that entire hierarchy, so I just stopped it with one level. That's all. You can either keep it as null, you can keep it as 0, or you can keep it as that number. It's up to us how we define it. Okay. Now, for question, what Amin asked is, see, Amin's manager sits in the employee table itself, right? What is manager's ID? 5. Who is that? Another employee. It's recursive relation, and this is how you implement it in your table. Now,
One more thing, sir. This thing, if in this the model which you have written, right? Let's just consider here the part which you were trying to say. I understood that part. Even what Nidhi was telling, I understood that part. What if we have a unique, like not unique, sorry, a value column here? Let's consider a value which gives you basically for a defined date. Consider like coming from financing, I'll just consider like a plan value or your quarter value, right? You have these two values, and suppose in terms of database, yeah, it is fine, you can write a query and you can fetch a details for it, right? But you have this unique columns, and you know that you have around 200 measures which you need to be created, right? And that will be basically processed in your front end. Basically, it might be in a visual way, or maybe in a advanced analytic way, or maybe in a analysis way, analytics, right? In that way. So you have these two values here. You will basically want it for your measures to be reduced. You need to do it and unpivot, because obviously it will come in an attribute and a value way, where you can just write a simple measure rather than writing a complex measure of each time pulling that value column, right? So that way, when you do that unpivot, your size increases, right? And even though it's a single table, right, and writing those so many measures, your process, your entire process, eventually in the database, I agree, you can fetch your things and you can write your SQL queries and the process will be faster there. But in the front end part, that process will be slowed down. Here, what I wanted to do here is, you have these tables. I wanted to create aggregated tables here, where I link it to the main data itself, your basically one entity, right? So in that process, I set a presidency where I tell the system that don't go to this table, right? Instead of go, because eventually the data size will increase there, and to process the entire data, it will take time. And imagine 200 queries running at the same time, it will eventually slow down the loading process in the front end, right? So wanted to create an aggregate table which is linked to this main table, which is the table which you have created here, right? And set a presidency that telling the system, don't go to the main table there. Go check the aggregated table there first, because the main table consists consider 200, 300 million rows there. And the aggregated table only consists of 4,000 rows. And that way I wanted to create a one-to-one relationship there. So that was the idea, and that was the question which I wanted to frame. Like if you get that question, or was it too fast?
No, let me I got something. Let me try to what else? Let me put net promoter score 50. Okay, I'll do one more thing.
Or we can take example of products in a store, in a departmental store. For example, if particular store product we have, and that product has different attributes. For example, comes in a certain category, certain price range, certain size or weight, color or usage, and that particular place could have multiple kind of products or have a single kind of products. That's also possible, no?
Since I understood that example. If this one doesn't work, I'll go to that. I think I should have started with that, but anyway, I wrote this much. I'll just complete this. 30, 40. What else you need? Implements quality. Bugs. Okay, another one, quality. What could be that? Bugs. Mean time for resolution. Okay, bugs 79. Quality mean time for resolution was 60 minutes. Okay, all this. Okay, now your this is how your table looks like. This is just for one customers, one BU. You have multiple quadrants, which means that there are multiple data points, which has multiple metrics, which has again sub metrics, and it has metric value. This is what you have, correct? And since there are like 10 million customers with maybe another 10 million BUs, this becomes a huge table. Your IBM has IBM India, IBM UK, IBM US, etc. So it becomes millions of records. And for each of this BU, you have like 10 metrics or 20 metrics, which makes it again like logarithmic way. It goes like that. So there are plenty of rows, correct? Now, your point is you want to find out an aggregated value for IBM as a whole, put a customer health score, maybe something like that, customer health index, which is based on a calculation like CSAT plus NPS divided by 40 in plus revenue into 100 divided by 30 plus etc. You have a calculation going on for all of these metrics to calculate the overall health index score, correct? This is what you are trying to eventually do. Since there are a lot of customers, a lot of BU, a lot of metrics, and 200 different applications connected by 200 different users trying to see this, it becomes very slow and is what you are saying, right? And so what you are going to do is you are going to build customer name, customer BU name, CHI score, simple. And IBM India CHI score is 70. If I go to write, is this what you're looking for? So that your front end application, when someone connects to it, and if he filters for IBM and IBM India, he will see 70 as the score. It doesn't have to, it doesn't hit this table.
Exactly, yeah.
So this becomes another table. Okay. This table becomes another table. So let's call this as base table just for the easiness. And this becomes your aggregate table. I'm just calling it as the name. That's all. Okay. It's just for the namesake, aggregate table and base table. What you do is you have this base table. You run ETL jobs wherein you have implemented the logic to calculate the score, load it into another table. The relationship between aggregate table and base table is, what would be the relationship? Can you guess?
One to many.
One to many. Correct. It should have at least one metric. Then only you will get a CH score. And it can have many metrics. So this is one to many. And from here, what it would be?
Many to one.
Did I answer your question?
Yeah.
Okay. Now, usually this is what this example came right like that because we are implementing this in our company. This is how we collect data. I work for customer experience team. We are getting almost 1,300 metrics for 4 different quadrants like sentiments, finance, quality, and sentiments, finance, quality, and what was the fourth one? I forgot. Sentiments, finance, quality.
Revenue.
No, revenue comes under finance. Oh my God, sentiment, finance, quality.
Yeah, sales also.
Sales also comes under finance. You have CXAT, NPS, annualized revenue booking, all those.
Resources.
Give me a second. Oh my God.
It's the same solution which even I'm trying to implement in my company. It goes like when I do that unpivot, the value shoots to above 1 billion rows, right? And the complex thing in there is the one which you showed, right? IBM India thing, right? So that keeps on changing or based on the business, right? And then that ID is unique to a particular business, but that ID keeps on changing, like considering two business, right? ID keeps on changing for that thing. And then the one which we have a relationship in the aggregate table, you always have to change that thing in that way.
Don't. I mean, if I was there, I would have. I mean, if I am part of that, I would strongly be opposing the fact that ID keeps changing. ID is your unique thing. It shouldn't be changing. I mean,
the first ID is unique. The second ID, it depends on the business. If it's what the business is happening, right? It's like consider this your premiums, commissions, and claims. Those kind of IDs, which are big, basically if the business is doing good and stuff like that, it'll have a different ID towards it. And then we have something logic in the backend which we created, which we override those IDs, right? Because certain times the ID changes, certain times the ID doesn't changes. But when it changes, there is a case for it. We try to override that ID. But doing that, trying to link it, it just becomes the process slow because the size increases, right? So
Understood. I can understand, but I think you don't have another option, right? Or maybe there is one way to do it. Okay, I'm just thinking you might have to check. Say, for example, let's say that this is what is keeping on changing. You have a dynamic ID which keeps on changing depending upon what business is happening. Your customer ID for IBM is 1 1 1 1 1, and this dynamic ID, say for example for IBM India right now it's 3. Okay, and so obviously here also your cust ID would be 1, your dynamic ID would be 3. Now tomorrow let's say that this business changes, instead of 3 this becomes 4. Correct? That is what is happening, right? And then you are being forced to come back here, change this ID as well because the business changed. Now maybe I would have done this way, which is how would I put it, AGT ID and base table dynamic ID. So let's say that here AGT ID, I'll put it as 1, okay, which is for IBM India. Now my dynamic ID is 4. The moment this one changes as 3, all I will do is I'll make a change here so that your upstream system is still the same. But again, you will have an extra join. And again, it depends on the efficiency performance. This is the only thing that we can do. Whatever that you're doing is kind of the same thing that I'm doing here, but this gives you more normalization and lesser updates to be done. Here you just need to update one record. Say for example, also do one more thing here. I put it as table ID. Okay, I'll put it as 1 1 1 1 1 1 1. This will be my base table ID. Now I'll just keep a mapping like this. What it does is your AGT ID is 1, your base table ID is 1, and your dynamic ID, there's only one entry for it, right? Now, if IBM India changes its business, you come here, you change the value here. When you do joining, it automatically takes care of it with just one join. So your application, which is running right now, still runs the same query, but you make a change, you make an update only in one place. I would have kept it like this, but again, the performance we need to check it. I can't sit here writing on an Excel and say that this is going to perform really well. No, it depends.
definitely, yeah, this is helpful. Yeah, thank you.
So, let me just start sharing again. So we went all to this many to 0 and many to 0. Now let's take an example of ER model. Okay, so this is a very common question that is being asked in almost all the universities, and what it is telling is that UPS is a company, you know, right? The courier shipment company UPS, and they are up to date with their information about where the courier is, etc. And for that, they rely on certain things like the item number, weight, dimension, insurance amount, destination, etc. And there are different attributes and different entities that they take into consideration. Can you go through this and think about how your ER model, not the relation model? I'm not looking for table relations as such. I just need the ER model where you have an entity as a square box and your attributes as the oval shapes one, how many entities would be there, how they would be related. Can you just think about it for briefly, like maybe 5 minutes? Just think. If you have a paper and pen, just try drawing it as well. Okay, so since we are approaching our lunch time, I'll just get to the answer. So this is how it would look, the ER model. Again, this is what they have implemented. You might have a different answer. They might have implemented based on their business knowledge, their domain knowledge, their infrastructure knowledge, etc. Okay, so it doesn't matter if this is not exactly what you got. It gets better when you are more informed. So what they are doing is they have the entity shipped items, which has all the attributes, which is the item number, weight, dimension, insurance amount, destination, final delivery, etc. Then you have another entity which is called as transportation event, which is related as shipped via, which means the shipped items are shipped through a transportation event, which has a type, scheduled number, delivery out, etc. Now the shipped items again also has a relationship with the retail center, which says the shipped item is received from so and so retail center, which has a type, unique ID and address. Now you see the relationships, right? A shipped item can have one or many transportation events. It can be through airplane, it can be through air, it can be through road, it can be through water, ship. So it can have many transportation events. A shipped item can only be received from one and only one retail center, correct? That is sensible, right? You can't get a shipped item from two retail center. Whereas a retail center can ship one or many items. A transportation event can have one or many items transported at this single go. Clear? Now, in addition to what we learned, you might be seeing these underlines, right? This is a way to represent which is your primary key, which is your intended primary key of your relation models table when you are implementing it. This basically means that when I convert this shipped items into relational model and implement it in DBMS, it will be a table. What are the columns? Item number, weight, dimension, insurance amount, destination, etc. And in among those, which do I prefer to make as the primary key? Item number. You make an underline there. We will see all these in the coming slides. Okay, underline what does it mean to have two oval shapes, etc. We will see that.
Sir, I have a question.
This is yes, please.
How can one shipped item can be shipped via multiple transportation events?
Okay, you are trying to ship a gift to your friend in Kerala. You are located in Delhi. You bought it. You went to which place? You went to Connaught Place delivery center, UPS center. You gave it to them. Okay. From there, the first transportation event is through a truck to airport hub. Then the next transportation event for the same gift delivery item is through air.
Okay, I get it. So there are transit points, but this
Correct.
information was not present in the statement. I got it now. Thank you.
Yeah, I mean, that's. I mean, I think retail centers and shipped items make their way to receive one or more standard UPS transportation events. Shipped items make their way to their destination via one or more standard UPS transportation events, that is flights, truck deliveries, etc. These transportation events are characterized by. Yes, sorry. No, I mean, it's okay. I mean, this is just a practice thing, so it's fine.
Yeah. So what I understood was from destination A to destination B, a particular item can be either shipped via road or via flight. I didn't thought that there would be
correct. I understood. So your transportation event is actually a movement of the shipped item from one hub to another hub. That's all. That is what a transportation event is.
Okay, sir, I got it. Thank you.
Great, thank you. So we will just, since few of them are in the campus and your lunch time is between 1 to 2, I'll just stop it here. We'll break for lunch. We will connect back at 1:45. Okay, and we'll continue from here. All good? Thank you.
Sir, can we have some more time? Maybe till 2.
If I say 1:45, you will be back only by 2. That is why I said 1:45.
Right,
if I say 2, you will be back only by 2:15. I used to come to your campus. I mean, not when I say you, it means students. Okay, not personally you or this batch. When I used to come to Reva campus, what happens is we break at 1. I ask them to come by 2. We'll wander around, talk, have a small talking break, and then come back around 2:25, etc. So then I started changing my strategy. I told you come by 1:45. Then at least by 2 o'clock I can start. Okay, so take till 2, but be on time by 2. That's all. Thank you.